Yes. So the recording has actually started. People were disturbing me with calls, but I think I'm now settled. Now we are going to the pure math. It is not working. What's not working? Seeing someone attending and I don't know that name is new. Sometimes people are sharing my link. Okay, it is okay. It's okay. Yes. Wait. This person paid. This person is claiming they paid and they are not in the group. They're the people that disorganize me the most. They wait for that hour. Oh, I've worked on them. So you people, for me, I gave you the plan of math 2, and I'm not giving you the plan anymore. You just see me teaching straight away. So math 2, I believe I did break it down. So someone tell me, before I begin on what we are supposed to cover, have I ever given you a breakdown of pure math? Someone tell me in the chat. Because I may skip something which is important. Or I may think I'm bringing good news, yet I'm not bringing good news. So did I try to break for you down math paper 1? Let me look for Ibrahim Sembatia. Ibrahim Sembatia is the one who likes those things of breaking down. You are on. Sembatia, soko ngambe. Did I break down math paper 1? Before I actually teach. You first tell me. Or anyone who recalls. Or anyone who has been following. Do you know the sections of paper 1? That is 1. Do you know how a paper is set? Same, but yeah, you can break down for some. No, did I break it down on Zoom? I don't know whether you know it or you don't, but I'm asking, have I ever tried to show you the breakdown here on Zoom online? That is what I'm asking, and it's what I want to know. And people are not telling me, even one who has never seen it is quiet. Sembatya ssebo ninze ggwe. Ndugga. Bannange. People are not serious today. Where is Emas? Emas is not here. Ndugga. So who is going to tell me whether I did those things or not? No. Last holiday. You are lying. Yeah. You are lying. Sembatya. Olimba. Last holiday. I couldn't. I don't usually do it as early as that. Nantume, have I ever did break down paper 1 this holiday? I'm talking of this holiday. This holiday you have not. Yes, but I don't remember the lesson very well. No, sir, no, sir. You told us how paper one is set at school, not here. Yes, at least that I can remember. I don't think that I've ever tried to break down. Do you know what I mean by breaking down? Mhm. Let me go with the majority. So breakdown, there are things you should be knowing at your fingertips. That the math you do is a principal subject. That's why when you get A up to E, it is called a principal pass. So the math you do is principal math. That's why even when they are writing the code, they begin with P. P meaning principal math. The subject code is 425. So this principal math has pure math. Up to now, people think pure math means A-level math. Nze nkola pure math, sikola sub math. Then you ask them what have applied. Bye bimu. Kale. So pure math is actually paper one. Applied math is actually paper two. That's the paper code. So I've said that pure math is paper one. Then applied math is paper two. What is it? Applied, I'm only demanding here distinction. All I'm demanding you here. Now, after your friends realizing I'm not picking, I'm not replying their messages, now they are calling. I'm not going to answer their calls. So today, I'm also, the Baganda who are here, okusibira omuntu entanda, how is it in English? Nantume, how do I tell someone in English that ngenda kusibira entanda? It's not a foundation. Like I'm wishing you well in the paper. I'm giving a plan for the paper. Paper two, all I'm waiting for is the distinction. You know our target is a 70. Pure math, our target is also 70. So it is today that we are going to see how, you see here, it's not that we are supposed to only cover work and cover work. Next year, you are going to spend more time without me. That's why I always endeavor to facilitate you more. In that even in my absentia, you have a plan to follow. Yeah, we're not going to be together the whole of next year. I'm also always kind of busy at medical school. You get? So that means I better give you a plan as I cover what I can in the shortest time possible and the best out of that time. You understand? So I'm also going to give you a plan for pure math. Chemistry, I've not yet given you a plan, but I only keep on giving you the course outline. I'm doing that intentionally as a certified, proved and trusted chemistry teacher, but not by profession. I won't give you the plan. I'll do that next holiday, where I'll be giving you now final facilitations, because when you report for second term, remain at school up to UNEB. First term holiday, just come to get final advice from me. As simple as that. This holiday is going, these are our last lesson. Yeah. Okay. Breakdown of pure math. So I can write the subject called principal math. principal math stroke 1, meaning paper 1, which is one. As we are breaking this down, we are going to see what is set in each. Just like you saw for math 2, we had a breakdown of how each of what is set in each. Yeah. So, as usual, we have section A, section B like that. So here we are going to have a branch. As usual, shall have a branch of pure math. Shall have a branch of pure math. Then we shall have how much? Shall have its contribution in section A. Shall have its contribution in section A. Then we shall have its contribution in section B. Yes. Yes. So what is the first branch in pure math? I will begin with the trigonometry. Without trigonometry, you cannot get even a B in math. Without trigonometry, you cannot even get a B in math. It contributes one of the least percentages, but it always comes up in the other branches. You find tree coming up in algebra, the same tree coming up in calculus, especially in calculus, the same tree coming back in geometry, the same tree coming back in vectors. You saw today we are dealing with a dot and a cross product. Trig was there. So this is something we can never escape in math. If you just have bias, you may not even get an O. Yes, because biasing trig is almost biasing the whole paper. So trig, there is said just one subject, sorry, one question. Set one question in section A, and then one question in section B. That is trig. Have a reason as why it is coming first. Yes. Then vectors. One A, one, you understand? Hmm? Then we have what they call algebra. 2A, 2B. That's what they call calculus. For me, I believe right now you are aware that a standard paper has 8 questions in section A and 8 questions in section B. So at this point, you should be aware of the number. Yes, you should be aware of the number. Yes. So if you look at what we have so far, the total is 7. 1, 1, 2, 3. That is 7. That means we are remaining with 1 question per section. And that comes from a topic they call geometry. Geometry. 1A, 1B. Today I'm going to give you what they call empirical. What they call empirical advice. Toxic but empirical. Toxic but empirical advice. Okay. Remember today is an overnight. We are studying up to 5 a.m. Those who think it's a joke, just stay tuned. But there are people I trust. Those ones we are going to be here. Hey, let me check. There are people I trust. They are going to be here. Dr. Melody, Anixike. Nduga will go off like at 1 or midnight. Emas will reach. There are people I know. There is Melo Presh. Melo Presh is Melo Presh will stay. She even always stays and listens to some music. Yes. We are here up to 5 a.m. So you leave us take our time. I'm going to give you today empirical, toxic, but yielding advice that you will not get from anyone. Okay, so that is the contribution. That is the contribution of each. That is the contribution of each in the someone is asking, won't we attend the biology today? But I've not said you dodge biology. You can attend. The good thing we record. The good thing we record. So you'll be in position to catch up. You can attend it both. You log on, understand something. You come back this side like that. Yes. Okay. Now, I told you that we have to have this long session to compensate some time we lost over the week in the name of festive holiday. So we are now going to look at what you need to know in each. I remember telling you that you need to know what is under everything. You cannot be there and say, for me, I'm a student of trigonometry, yet you don't know our formula. What you do not know is what UNEB is going to say. So as you just boldly say that, may I do trig, I'm a student of trigonometry, first ask yourself, what is done in trig? You understand? What is done in trig? Do I know each and everything done in trig? Yes. Period. And that is enough. But if there are some things which are not yet clear, you work on them. Because UNEB is going to pick those. So to begin with, trigonometry. Trigonometry, where they set 1a, then 1b. A. We all know these are 5 marks, these are 12 marks. Yeah, so we want to see how does one actually get that 17%. So that means in every standard paper, you can, if you are a student who is good at trigonometry, you can get a 17%. After doing the section A number very well and the section B number very well. Remember, we are on a journey to 70%. So let us see how can actually this 17% be achieved or yield. Yeah. Let me first read these messages in the chat. Maybe leaving some people behind. Okay. In this trig, we have different formulae that we use. That one you have to understand. This trig, what actually makes it hard, first and foremost, are the formulae that we use. So someone may ask, what are those formulae that I'm actually talking about? We have the trig identities. We have the trig identities. What I'm teaching you is you guys having a sense of the paper. Trigger identities. Trigger identities, give you some examples. Giving you one example so that you easily click it. Because someone may be like, what are those trigger identities? Yes, trig. So you people, let me hope, is my screen there still visible as I'm writing trigger identities? Do you see it clear? Trigger identities, sine squared x plus cos squared x equal to 1. Yes, then I'll say it is because you'll be in position to know others. So after that, which other formulae is looked at? We have what we call compound angles. Yes. Sine A plus B. Cos A plus B. Tan A minus B. etc. Those ones should be aware them. Let me teach you something new. There is even what they call tan A plus B plus C, etc. Here I'll put this symbol. Are you seeing the first one on sine? Sine A plus or minus B. Either plus or minus. Those are what we call compound angles. Then etc means even cos and tan. I'm just giving you a general picture that will remind you of the rest. Okay. Then we have what we call the double angles. Yes, double angle. Formula. It's double angle formula where we deal with sine to x. Then we say is 2 sine x cos x, where we deal with cos to x and many others. And then you have to recall that double angle doesn't actually only mean cos to x, it can even mean cos for x. You understand? It can mean sine 10x. Now those are things you should be adding on your own. That's if you're taking note or you take notes during the by the way, I pity those people who wait for the PDF and copy notes. It is a bit sensitive for you guys. Because sometimes we do more of speaking than writing. So, the other formula, that's what we call the half angle. So we have what we call the half angle. Angle formula. Big, that one where we say that sine squared x. I remember briefing here about this in integration. We say 1 minus cos to x. I remember telling you it can be for something else, it can even be for this one. Understand? Yes. It can be for cos, and the angle can be a fraction, etc. I remember briefing you in that half angle formula. Yes. What is the other formula? What is the other formula? There are so many. You have factor formula. You have factor formula. So factor formula, I remember briefing you in integration where we are doing something like cos to x plus cos for x. I remember briefing you sine 4x. Why am I overusing sine 5x minus sine 3x? Yes, then I remember telling you that expansion formula is the reverse of, so this is what they call factor formula, and its reverse is what they call expansion formula. Yes, I also remember telling you about the reverse. You recall, it's what we use in integration. So I'm going to be asking which other formulae still going of what we call our formula. Yes, of what we call T formula. So I want to ask members, which other formula do you know of that has not been talked about? Told you that we are breaking down the paper. I don't mind whether we are breaking it down until midnight or until 11. I don't care. What I'm giving you now is what I'm just giving you the feelings of the paper. Every time I mention something and you be like, yeah, that one I know, there is a vitamin you get. And you can only get it from a live lesson, not a recording. By the time the recording is out, the vitamin is no longer in its active form. I'm telling you. So you stay on, be patient, just watch the flow. Just watch the flow. Just like you can give a movie over 2 hours or TikTok over 3 hours. Just stay here. Don't be like, I'll wait for the PDF. Those things will be clear. I'll just watch. You will miss the vitamin. A multiple angle formula. Multiple angle formula is everywhere. On each of them, multiple angles can come through. Yeah, just like I say that double angle can be in form of 8x, 10x, and so on. You get? Okay. Now, what am I saying? That is part A for trig. You need to know all those formulae. This is what you have to keep up to your last day of UNEB. Let me not waste time. Part B. What else do you need to know in trig? Use of the formulae in A. Let me hope you have downloaded those papers sent in the group, yeah? Because we are going to use them around 9:30. We are going to use each and every paper sent there. So make sure you download them, yeah? Yes. As we are checking through them, there is another vitamin you are going to give. So the question is, what are the uses of those formulae above? Roman 1. Proving trig expressions. Proving trig expression. These are all things we are going to see. Proving trig expressions. E.g., I can say, prove that sine theory theta, prove that sine theory theta is 4 the cube of sine theta minus 3 sine theta. But do people know this thing? Do people know these things? Do people know cos and sine? But you don't need to cram. So they can give you such a question. Yes, until you prove that sine is that. You know such questions. So you may need to use any of the above. Then Roman 2, solving equations. Solving equations involving trig functions. Considering different angle ranges. I'm going to be so hard here about angle ranges. Angle ranges, you all know, there is when they tell you 0 degrees. In most cases, it is theta. They end up 360. There is when they give you 0 theta, 180. There is when they give you 0, you don't put degrees, say up to pi. Yes, there is when they give you negative pi to 2 pi. Yes. There is when even they can give you negative 90. Anything can happen. 360. Their target is maybe 270. Yes. What am I trying to show you? That you can have the normal range, they can shorten the range, they can bring it in radians, they can have a negative either in radians or a negative in degrees. And I told you the difference. I told you, sorry, the similarity between a rad and a degree. And I remember telling you that 1 rad or pi is equivalent to 180 degrees. I remember telling you that. Those who didn't, you actually try it again. Yeah. Now, I'll put an example of the question. Because someone may be like, what do you mean by solving? How do these questions actually come? Question may be equals to x minus 3 sine squared x plus 3 equal to 0. It what? It is C. Not only that, by the moment you see such a question, it is urging you, whether you people, this is what they call the triple angle identity. It is rare, but we can have it. Yeah? We can just have it here. It is usually set as a question, but it is not always considered. Yeah? Triple angle identity. They don't always prioritize it as using it directly like others. For it, they always want you to prove. In most cases, they want you to prove. Yes, you can even go and check UNEB, which I call USCE 20 and 23. There was some number in section B. Yes, they always want you to prove them, but they also actually X is triple angles, tan 3x, something like that. We are on uses of the formula in A. Roman 3. What else? Elimination. Those things are used in elimination of theta. Elimination of theta. I don't know that I've ever seen those questions. ED, they tell you sine theta is x, cos theta is y. You understand? And then they give you conditions that are going to make you eliminate that theta, like it or not. Yes. Hope that is okay. So you are always forced to eliminate this theta. So they can tell you eliminate theta E something like that. So they want you to find the expression or the simplified form of cos 3 theta. Then you make adjustments where possible. They tell you, they can even give you Romans. They be like in 1 cos 3 theta. Roman 2, they say tan theta. Roman 3, they say sec to theta, like that. It what? etc. That means and so many others. So, and if at all you are in position to do all that, that will mark the end. That will mark the end of trig. End of trig. So as a student who says that for me, every time I open a UNEB paper, I must do trigonometry. This is what you must ensure. Do I know all the other formulae? Yes. If yes, can I use them to prove some trig expressions? That one has no yes or no. You just do as many as you can. In doing so, you come up with certain there is actually part C. There is part C. We are going to talk about part C before I say the end. You ask yourself, can I solve some equations with the different ranges? Do I know how to deal with them? Elimination of theta. Do I have some questions on eliminating theta? Someone is like, how do you do when to get negative angles? Teacher, you haven't talked about triangles. Yeah, that is part C. Yeah, angles in a triangle. But that one is a proof, yeah? Always put it under proof. Yeah. Always put it under proof. Because literally, those are things you are going to still use. I'm telling you. By the way, let us not make it something so, because even angles in a triangle, that's what we always do. And I always see people biased about it. So I'm going to put here a note and say, angles of a triangle because most questions that come there are in proof form. So I always consider it under proofs, but we can make it independent and say angles of a triangle, angles of a triangle here. What do you need? Need to ensure that you know how to deal with the sine rule. Sine rule. So find out what the sine rule is. You must recall the cosine rule. It may also be of help. We saw that today. Under vectors, we talked about it. Then the other thing, should also know something about special angles. Yes, special angles. For them. Special angle formulae. Ig sine 90. So 180 minus b, etc. Those are things you have to be knowing. They have to be at your fingertips. Yes. So angles in a triangle, very important. So with all that, the questions that come here are actually proofs. Yes. We are going to check on them in the various papers. Yes. The three above plus knowledge in A enables a student attempt the proofs under angles of a triangle, which is C. You understand? So the three above, I mean this, sine rule is 1, cosine rule is 3, then special angle formula is that one. Those different things we come up with, yeah, as we are dealing with those angles. So I told you that here I'm wishing you well in the paper, even in my absentia. If you have such a summary, go to your teacher, tell them I have issues with cosine rule. However much we cover without a plan, you'll be confused, I'm telling you. So the questions that come in this case, Iggy, I don't know if actually someone has found us a question, because someone may be like, what exactly, which kind of questions actually come in this case? I gave you paper 1 notes. Do people have them? Notes of pure math. Those notes actually have trigonometry. You understand? So they always tell you that prove that in a triangle, and most of the questions, these questions, most of them do not change, because they are actually there. They are actually there in backhouse. That's where most questions are picked. They do not change. In the notes I sent you, you can check page 95. I don't know if people have been keeping my notes. Page 95, that's where most questions are. And these questions I've said do not change. They are mostly picked from what? From backhouse. But we shall try out some. Yes, we shall try out some, and that's what we shall be doing in those other holidays. I don't want us to do a lot of things. So they can say, prove that in a triangle. These ones are hard ones. But we can just mention so that you at least have. This is actually a UNEB number. You say that prove that in any triangle ABC, that's how they said, prove that in any triangle ABC, prove that in any triangle ABC, prove that in any triangle ABC, S squared minus B squared out of C squared is equal to sine A minus B out of sine A plus B. Then I'll put here etc to show you that there are many others. Yes, but I'm just giving you the format of the question so that you realize that, oh, this is what the teacher means. Because if I just state that Simanya enables us to attempt question under C, you may not get it. But if you have an image of what actually comes under C, you can now get all such questions. So you need to know a lot of work. You know the sine rule, you know the cosine rule, you know some of those special angle formulae. Yeah. So with that, you'll be good to go. Attempt questions and see something like that. So with that, trig. I think you can see just one number, but you're going to see that for other sections, there are not actually many words. And that's why I actually begin with the trig, because for it has a lot of stories to tell. I told you that trig will always come through in calculus, it will come back in geometry, it will show up in vectors as you saw today. In algebra, it is too much. Everyone who wants to set a trick in algebra thinks of trigonometry. So just know there is no way you're going to escape it. That's why it is having a lot of things under it. So I repeat one more time that a student who says that for me trigonometry is my thing, if you need the 17%, the work you need to know is as much as the 2 pages you're seeing on board. Don't complain that I don't know what R formula means. R formula, you know. T formula, those ones are talked about. Yeah. T formula, you people are good at giving excuses. Let me just tell you some secret about T formula. So T formula is the one that you all know. That if I want sine to x, the one where we say if tan x over 2 is t, then we say it is difficult, right, when I over zoom the screen in. So you will bear with me. Sine to x, sine to x will be actually sine x. If we consider tan to be x over 2, the others of sine and cos will be simply x. 2t out of 1 plus t squared. It is the one of t formula. Then you all know that for R formula, this one is done systematically. It is not obvious. It is done systematically, depending on what is in question. Systematically done. Systematically done. Yes. Don't want to leave any stone unturned. T formula, let me hope you have recalled it. Yeah? It also has the etc part. It has the cos and so on and so forth. So that is the trig part. Allow me now go to vectors. This one is going to take just a minute. These others now are easy to deal with. It is trig that is too wordy for reasons I've actually given. Part B, this is where we're going to see our vectors. vectors where we have 1a. I think it is supposed to be 2, not a. It's supposed to be 2. And also 1b. Here, marks are 5. Here the marks are 12. So the same thing also here. The vectors will be giving you that 17%. So 17 and 17, that is 34, already out of the F9. And I always tell you that the way I write them should be the order of attempting. So you like it or not, you must not trig by force. You must be knowing vectors by force. You must be knowing algebra by force. And you should be knowing calculus by force. That one I'm telling you the fact. These vectors are easy to deal with. The concepts are just minor. Now, what is in vectors that one is supposed to be knowing? You know, I'm currently teaching you vectors, isn't it? And those who have looked at our course outline, I don't know whether I gave you the course outline, but at least I know I gave you the book. So a serious student must have gone an extra mile to look at what is exactly in these vector stuffs. What do they set? That was appreciated in the introduction, those at least who were attentive with me. Now in vectors, it is all simple. They just look at that O-level review, the one I gave you in the first lesson. Then they look at lines and planes, period. And remember, we are going to do vectors today still, because I want us to calculate first. After calculating, by the time I start covering some things, you know why. You know that there is a target for that. So under vectors is all easy. What do they do first? We do what we call vectors in 2 and 3 dimension. Let me just say we do what we call vector algebra. Vector algebra, that is one thing we look at. Someone may be like, what is in this vector algebra? So I'm going to tell you. In this vector algebra, those who recall very well, a lot was done here. A lot was done in the vector algebra. It is this vector algebra that we find dot product. This is where we find, let me begin with unity vector. We find position vectors. Vector algebra is where I find point A, point A. Understand? Maybe point XY. You understand? Then this point A, I need to know that its position vector, or A, or what we call the small a, but you have to show it is a vector, which is x with I is a unit vector, plus y, you get. Then j is a position vector. One can write it in column form as x over y. You understand? Then it is this same place where we found the unity vector of A. Where unity vector of A, what to begin with, let me begin with the magnitude of A. This is all in vector algebra, right? Where in magnitude of A, we agreed that we get the root and sum the squares. Get the root Then sum the squares of those two. Then finally, we form the unity vector. Where we get the vector, unity vector, you recall it is written like that, where I get the vector over its magnitude. Those who attended the first lesson on introduction, I don't think anything there should confuse you. You start with the point OX, you go to the position vectors, you go to the magnitude, unity vector, those things. It is still under vector algebra that you find something else. Things we covered today. I'm also going to talk about them. Then this same thing where we find collinear vectors, telling you that, and parallel vectors. This is all in vector algebra. Parallel vectors. And coplanar vectors. And dot product. And dot product. So I find cross product. Where you find area of a triangle. Then this is in the same place where you find advanced concepts. Find advanced concepts. Or level vectors. You need this summary. Okay. Vectors, I'm just teaching them, so I may not give you a clue of a kind of a question. That one you need to find out on your own because you actually have the document. Do you also have parallel lines here? You're going to see that in part B. Yes. Then lastly under vectors, we have what we call the ratio theorem. Yes, lastly under vectors, we have what we call the ratio theorem. It's under vector algebra. So I gave you the above. There are no need. Because collinear vectors, questions always come and say show that the vectors are collinear. Parallel vectors show that they are parallel. Coplanar show that they are coplanar. Dot product, you know we use it in getting angles. Cross product, you know we use it to get perpendicular vectors. Yes, now these ones will come in later cases when we are revising area of a triangle. We talked about it today. Advanced concepts of O-level vectors, same thing. Those ones I gave you as assignment. Ratio theorem is going to be handled soon also. Something like that. But remember that is just part A, which is vector algebra. A level is not easy. Getting an A is not easy. So we go to part B. So we are going to part B. You people, your network is stable and you are more than 40 people. So you have to be on to get that vitamin and my blessing as well. So here, what are we going to do next? We are going to look at the lines. We are going to look at the lines in 2D and 3D. In the very introduction, I remember telling you that a vector in what? In 2D is the one with only the x and what? And y. And the one in 3D is the one you get 2 for 2 axes, 3 for 3 axes, in addition to the z axis. That's what it means. And you will see, the things we do here are not much. They are nothing. They shouldn't even confuse you any. Because what do we look at? For example, under a line. Someone may be there. Yes, you have said a line. What is under a line? So I have news for you. Those who are asking. What do we have underline? Underline, we shall always get what they call vector equation. Vector equation of a line. Vector equation of a line. Then of what we call Cartesian equation. What we call of a line. Yes. Of parametric. These are things we are supposed to cover next. Parametric equations. Parametric equations of a line. Should be knowing the angle between lines. Should know the properties. You should know the properties of parallel lines and perpendicular lines. Of parallel and perpendicular lines. Properties of the parallel and perpendicular lines. You get? Not so hard. So when you hear of lines under vectors, you ask yourself, can I be in position to get the vector equation? Can I be in position to get the Cartesian parametric ones, the angle, the properties of the perpendicular and the parallel lines, such things. But as you know, we are not supposed to forget our thing of it what? etc. Whatever we talk about, you have to add on it what? etc. Such that you see those tricks. etc is for tricks that come up combining those concepts, especially to do with the relationship between a line and a plane. We are going to be seeing all that. Just stay tuned. We are here up to 5 a.m. and I warned you already in the morning. Hey, those who have not been aware that we had the overnight, it is too absurd. So part C, we're going to look at planes. Yes. Yes. Planes, they're the ones that are in this format. Someone will be like, hey, don't we have planes in... Someone will be like, don't we have planes in 2D? No. Yes, because of how they look like, you can see they go up to Z. That means these planes are only and only in 3D. Yes, only 3D. Yes, so even these planes, the same thing. You must know how they get the equation, you must know the angles. Yes, you must know the properties, such things. So you should just be organized and be like, what are some of those questions that ask about parallel lines? I'm not going to put an example on each. You realize if I put examples, it is going to be too wide. But a serious student just gets a math clinic, a math QB, any math pamphlet, go under vectors, look for those questions under lines that ask for angles if you have issues there. Do the needful. Look for those questions that talk about the perpendicular and parallel lines. Do the needful. Something like that. None of us here is below 18 years. So I believe you know what to do. I just trust you at that. So about the plane, yes, should be in position now. Get the Cartesian equation of the plane. Cartesian. So here's something that we forgot. I'm going to fix it here. This is what we call the point of intersection. The point of intersection. The point of intersection of two lines. The point of intersection of two lines. It is something that you should not also take lightly. Yes. So here we need the Cartesian equation of the plane. Yes, we need the point of intersection of two planes. When I told you, as I'm setting this course outline, the subject becomes part of you. So you get that vitamin of temporarily assuming tightness to the paper, to the content of the paper. The point of intersection of two planes. Then the angle. So you ask yourself, can I actually get an angle between two planes? Angle between two planes? Even have books I send. I don't know what you people actually need. Angle between two planes. Then ask yourself, do I know some of the properties? Do I know some of the properties of parallel? It is hard to draw a plane. So here I will write of parallel and perpendicular. I told you in the morning that the word perpendicular is the same as normal. I was saying perpendicular, in brackets, normal. So when they say normal planes, you think of that word, perpendicular. So I always tell you that our ETC will always be there for us. In Luganda they say, ebeerawo awo ku kiddo. Then the other last part, part D, is the relationship. It's the relationship. The relationship. The relationship between a line and a plane. Between a line and a plane. So what is the bad news? What is the bad news? What is the bad news here? What is the bad news right now? That unlike your relationship, the relationship between a line and plane is a happy one. I don't know whether you get the meaning of that statement. That unlike your relationship, the relationship between a line and a plane is a happy one. So, what are those concepts that we look at in the relationship between the two? Why are you quarreling? Yes. We need the point of intersection and we need the angle between the two. Okay, so we shall need the point of intersection. Shall need the point of intersection. Shall need the point of intersection. Shall need the point of intersection of a line and a plane. Then we shall also need the angle between. Also need the angle between. The angle between. Also need the angle between. Also need the angle between. We also need the angle between a line and a plane. We are also done with vectors. Those are 34 marks. So you have no reason to actually go off because last time it was hard for you to raise 34%. And me and you know that if they had not at least briefed you on what was going to come, you couldn't actually pass. If they had not actually briefed you on what is going to come and even did for you some of the questions, you are not going to pass. What we are planning for is a UNEB paper. Which UNEB paper, they are not going to tell you the question is coming. So you must just have something general, you know that they said this, this, and this. You understand? Then as usual, the ETC is always there, Kuchido. And guess what? That is the end of vectors. So no one should ever and ever lie to you that there is something beyond that in vectors. However, we have our ETCs on each. So every time you come up with something that we have not talked about, ask yourself, where is it exactly falling? Under the relationship, under planes, under lines, under vector algebra. You get? So every student who is on this platform and is a student who looks at vectors as their thing in the national exam, there is your page. There is your page. So every time you are going into an exam, you have to revisit this and be like, so you just keep on ticking. So you will overwrite this paka kuwulira bubi. So that you tick. Every exam you are going for, tick. What you don't tick is what you're going to find in an exam. That means the knowledge of the other is a wastage of time for that exam. I told you that you may believe in perfection. I don't believe in kasavu kanyama, knowing something on everything. What you know is not going to be said. But if I know my two things perfectly, they are going to bring those, I pass those. I avoid the F9. Period. Perfection came to avoid F9. Yes. Then that kasavu kanyama thing of knowing something on each at least is for people who think they have luck. And luck is just 1% at A level. Most of the luck will come through hard work. In that in your course of reading too hard, what you understand most is what comes through in the exam. Yes, so you stop that propaganda of luck. So that is just algebra. Imagine just one question, full page. Trigonometry, which was still also a question, 2 pages. Now we are going algebra, 2 of them. So what do you expect? Up to 5 a.m. Yes, even if I just facilitate you up to morning, me I will know you have the entire of the year. Yes. We are going for 3. For 3 algebra. Now here, this is where you have to be. This is where you have to be super and super, super and super. Why? Because these 2 questions of section A, there are 2, each carries 5. Those are 10 marks. Then 2B, there are 2, each is 12. Those are how many? 24. That means algebra alone in the exam is 34%. You get? The first 2 we have done. Just listen how easy A level is. The first 2, it is 17 and 17, which is also 34. Algebra is also 34, which is a total of 68. Meaning you need more 2 marks to get 70, which is a D2. So that means, I will not make that statement. How dare you fail these papers? Trig and the vectors, you are already yielding a 34. Algebra 34, that is 68. Let us remove 18 marks for errors. 18 marks for errors, that is a lot for someone who has been doing practice, but I've considered them. That is a 50, which 50 is a credit 5 at UNEB. Credit 5. Credit 5, that means you're going to get a C. On top of not knowing anything in calculus, on top of not knowing anything in geometry, I've added on 18 marks for errors for you to get a 50, to get a C5 and come up with a C. I'm going to I don't that's that just because I don't want to share marks of your friends, but I would show you one of the UNEB booklets, like the results UNEB sends on the portal. You will see 4 and credit fund credit 5 is a C. D1 and the C4 is a B. just because you guys are given a C in most of your schools. But UNEB, D1 and a 5, D2 and a 5, C3 and a 5, C4 and a 5, it is a C. Unless you get 2 credit 5, that's when you get a B. All this comes. People, are you feeling how easy it is? People fail to get them because of planning. They go into an exam, they don't know what they are going to do. For me, I used to be this kind of student who says, let me go to section B and see what has Trig said. Can I do? And remember, in my brain, I know the format of all tricky questions. So I read the question and be like, this is a proof one. So I need to use any of the formulae. Okay. I see that this is maybe solving equations. That means what is it applying? Half angle factor formula, such things. I say I'm going to do vectors. What is it about? Only planes, only lines, vector algebra, a combination of any of the two, a relationship. When I'm aware, and those things can actually become part of you. Just believe in yourself. So we are now going to algebra, which is a must know. And you're going to be surprised that under algebra, it is only one topic that you don't know, which is permutations and combinations. But we are going to talk about each. So by the time algebra is done, we have 68%. You get? You understand? 68%. That means you have more 2 marks into 70. Hey. There are my friends who are going to be asking me for paper 2s next term. You will see how easy this subject is. Chemistry, I mean. Even math is easy, but you will appreciate the ease of chemistry. Just know I'm cooking. I'm cooking. What is in algebra? What is in algebra? Let me first give people a chance. I don't want the discussion to overbeat each other best. We are here up to morning. You force yourself. I know men are dozing. You keep dozing. I want someone, you just raise up your hand. Don't send a text. You just tell me a topic in algebra. Just a topic in algebra. That's what I want. A topic in algebra only. Okay, you can text. If you text, you tell me 3 of them. If you talk, you give me 1. If anyone knows all of them, I'm going to give you 25K after the lesson. Yes, because there is someone who actually just paid when the lesson had just started. I will give you that money. Yusufu, I'm seeing you online. Yusuf, on Sunday, you look for me. Nja kujjaawo ne mu Australia nkubuuzeeko omuyiribi wa Simos. Yoyeko omusajja omuyiribi gwe tulinawo. Someone, you either raise up your hand or you text and tell me some of the topics in People are giving me topics of all level. Okay, let me see. Alison. Alison, you unmute.
The topics under okay, the subtopics under algebra, we first have the surds, the logarithms, and the indices. Then we have the quadratics, the polynomials. Then we also have the binomial theorem, the complex numbers, inequalities, permutations and combinations, and then series and progressions.
Oh, thank you. Alison, you want to become a teacher? Alison, you tell me in the chat. What is your dream course? Okay, what is your dream occupation? You see people trying, people are struggling, people are giving me linear program, linear programming, functions, bearing. Let me hope it's a joke. Addison, you tell me, do you want to become a teacher? What is your dream occupation? What dream course? Teacher, I want, hey, okay, that is nice. Let me tell you my dream occupation. For me, my dream occupation, even when I was growing up, I used to just tell my parents I want to be rich. Yes, I want to be rich. Even now, even if you ask me what is your dream occupation, I tell you I want to be rich. I was very young and very many people used to ask me because I used to be the first in my school from baby class up to senior 6. So everyone was asking me, bw'okula oyagala kubeera ki? Ngamba nze njagala kubeera mugagga. Samantha, what do you want to tell us? You raise up your hand again. As if you are raising up your hand, Samantha. Yeah, those one not saying anything. Okay, algebra party A. Here we have indices. Indices, surds, and logarithm. Most people thought, you people are wise. Most people thought those are, most people thought that is one topic. Yeah? So for you, I just want you guys to have it at the back of your mind. The topics of algebra are 9. 9 topics. So we are going to break them down and see. So what you need to know here, actually, the laws of indices. Yes, even here it's under sides, you need to know the laws. Here you have to know the laws. Yes, these ones actually come through every way. These laws, they come in a lot of proofs. Solving equations. They pass so many times. Other applications. So many times. Other application. As usual, the ETC comes through. I don't want to over talk about indices. Yes, just make sure you know the laws of all. These things are actually revised in terms of numbers. Yeah? It's not good to revise math. You state laws of indices, laws of SADs. No, you simply do a lot of numbers. They are still together. Shall see what God has actually prepared for us to do. Then part B, we have what I call roots. Roots of a quadratic. I call roots of a quadratic and cubic. Roots of a quadratic cubic equations. You know those questions where they usually use alpha and beta? Yes. Then for cubic ones, they always use alpha, beta, and gamma. Yes. And for that case, there is something you always need to know as well. You must always know what that can give you. Always know what this one can give you, the one of cubed. Always know what the one of 4 can actually give you. Should know what the difference of two squares can produce. Should know what that one can produce. As usual, the ETC comes through. Those are things that people are aware of. You're not seeing them for the first time. Roots. So this is strictly on roots. Part C, come and look at what we call equation. Yes. Under equations, I'll need those equations we are dealing with solving. What we call simultaneous equations. I'm going to tell you something about the simultaneous equations. So simultaneous equations, you must be this person who can deal with 2 or 3 unknowns. People may see that as 2 over 3. I mean 2 or 3 unknowns. Yes. And for the case of the 3 unknowns, you should be in position to use row reduction. Should be in position to use row reduction, what they call echelon, or call echelon method. That one they usually tell you by using row reduction by echelon. Sort of. So as a serious student, you just look for those questions. But I want this thing to be interactive. You ask me, like those people are asking, sir, what of these questions that ask this and this? What of this? Don't just be quiet. This is not, I'm not giving a sermon. This is a lesson. We have quadratic equations. Quadratic equations. A should be in position to do those ones. They can still set for you. You should be in position. Cubic equations. Yes. Should be in position. Cubic and aquatic should be in position to handle those ones. So what people are saying. So sir, they only set a simultaneous equation of 3 unknowns here in A level. No, you check it 2019. You check 2019. There is a year where they set 2 of them. I think it is 2019. 2 of them. Yeah, it is over number 14. 2 of them. They set 2 of them. And the unknowns were only X and Y. They are those that they call symmetric equations. Yeah, so you should go to your math teacher and be like, sir, I want to do this algebra. But under algebra, they always set equations. I know all the others, but I don't know symmetric ones or symmetrical ones. How do I deal with them? Yes, so that your senior 6 is organized. But the moment you lack organization, that's how failure is going to come in, despite the hard work. So those two should be this person who is good with factorizing them. Factorization is also key, because literally you cannot solve without being a god of factorization. So you must be in position to factorize before you actually solve. So I think you can see a factorization is also not, it's not a joke. It's not a joke. Yeah, then D, just put here, just below it, the inequalities. Inequalities. Yes. Inequalities, of course, what we are talking about here is solving. Yes. Inequalities, of course, what we are talking about here is solving. Yes. Solving, just handle all cases. Just handle all the cases. Learn how they actually deal with the greater than, or equal to, the less than, or equal to, and etc. Application. So you may be there and be like, sir, what do you mean by application of inequalities? What are those questions? They always come in some other application of inequalities. You see them coming up in other topics, like the one I'm mentioning next, the series. So somewhere in series, you will see inequalities coming in. So you don't blame the topic for not having application under it. Yeah, it's the other topics that actually need the concept of inequalities to come in that should be blamed. Yes. So now part E. Remember the topics are 9. And E is the fifth series, so we have more 4. Hey, you are joking. Getting an A is not easy. I taught series. Let me see what people are saying here. So there are cubic equations with conditions. So substitute this one. How about modulus inequalities? Yeah. That's why I'm saying look at all cases. There are those cases with or without modulus. That's what I meant. Those where you substitute, they are the symmetrical. Yes, I remember telling you that cubic are the ones to power 3. Cubic, you're having our x to power 3. Then quartic is x to power 4. Power 5, not part of the syllabus. So series, what do you need to know here? You need to know we have what we call the AP. You get? So what do you need to know in AP? In AP, you need to know the formulae applied, the formulae used, the formulae used as is stated, in the logbook. Yes, the logbook has all those formulae. So after knowing the formulae used as stated in the logbook, you should know the meaning of each denotation. This is something we have been seeing since day one. That in every topic where denotions are used, ensure to appreciate the meaning, because even the syllabus book urges you to understand. Iggy, I told you series last holiday. We struggled with the series. Hey, make sure you know what is A, what is D. You understand what is N, what is UN, what is SN. Such things. I always say it what? ETC. ETC will always come through. One doesn't disappoint. ETC. You can as well have a clue on the application. What is the application? Application of these things usually comes in word problem. Word problem is something you've been knowing since primary. If you went to a good primary school, not like us. Told you from where I grew up from Nansan. And my dad was a friend to the chairman. So we are the celebrities of the school, because the school was actually owned by the chairman. So it was very easy. So the GP, same thing. Appreciate the formula used. So here I'm going to just say same. Yes, same thing. Even after writing that arrow, I will say same. Same. After saying same, we shall mention here some new terms which are not there, like R. You should know what R is. You should know that this side they use R, which is the common ratio. Then the other side they use D, which is common difference. We have this side, we have sum to infinity. As usual, etc comes through. Should not forget also this side. Talk about the application. Application on interest. Yeah. Compound interest. CIA. So many. There is also that one of carrying decimals. So you just ask your teacher, I heard that there is a question which is under. No, it's not a matter you should cram. You just keep on visiting this. It's not a must for this one to be in the head. It is just there to help you weigh yourself. Am I still in line with the distinction I need? You, after looking through it, realize there is what they call recurring decimals as an application of GP. So you ask your teacher, how do they set those things of recurring decimals under GP? Can you please get me some question? Yeah, the teacher will know that the student is serious because you are on a mission of ensuring series are okay. By ensuring that you are securing a question in algebra, you get, and by that you are securing a question in math paper 1. Yeah, because you will leave out this and the person setting will pick that. And will not consider all those ones, the ones of AP. The moderator will pick GP. On top of picking GP, they will not even pick sum to infinity. They will go straight away. They will even skip compound interest and go to recurring decimal. The ETC part is just there for you to keep on revising. You look for those new tricks. So ETC is about the tricks. The night is still young. We have more 7 hours. More 7 hours. The recording is going to be 10 hours. You think it is a joke? Hey, 10 hours. The cloud storage is going to even get full. You are joking. So that is it about series. Just series. Look at what you have to know. Hey, people on, thanks for being patient. I just want to maintain 30 participants. Up to that time, I want to stop. And if you stay on without getting disturbed, there are people I'm worried of. You can study near the socket. Those are going to be disturbed by battery. If you stay on up to when I give up, God is going to bless you. June Angel, you leave my screen. Yes, you have started dozing. Those people are going to stay on up to the time we are ending. God is going to bless you for your endurance and perseverance. We proceed. Part F, what is the 6th? What is the 6th? We have what we call a binomial theorem and expansion. People be there, they even think binomial theorem is the same as expansion. So binomial theorem is the one that looks like this. A plus B power n. Yes, it is this one. Then binomial expansion is the one that looks like 1 plus x power n. These ones are in the logbook. I don't want to state them because people have actually forgotten, so I don't want to speak a lot that is going to bias people. Formally in the logbook. Abigail. Is Abigail on? Abigail, you check the formula for binomial theorem and expansion. It's going to disturb you, but you look for it because I don't think they're even near each other. So this one is called the binomial expansion, though I'm not putting the word there. But let me fix it. Binomial expansion. So I'll come and write it here. It is also called binomial expansion. So binomial expansion is the one of 1 plus x to power anything. Someone may be like, but what do you mean? How do these questions actually come? You show us. It's okay. This one may come in a way that it is 2x plus 4y maybe power 8. That's what they call binomial theorem. For binomial expansion, something like come like 1 plus maybe 3x power negative. You get it can come as a fraction. 1 plus x over 2. The power can be a positive 3. Can come as a negative 1 minus 5x. And then this one is a fraction, maybe 2 over 3. Like that. That is for binomial. That's what they call binomial expansion. Nachiganda. What are you saying, Nachiganda? You raise up your hand again. So this is for binomial expansion. The power can be a negative, it can be a positive, it can be a fraction. Then for binomial theorem, something like that. Yeah. Something like that. And for binomial theorem, n b n should be 1 etc. We don't have issues. Binomial expansion, formula 10, page 60. Yes, Abigail is saying. Formula 10, page 60 for binomial expansion. I told you that one is a trusted source. Binomial theorem, will you see it? Huh? This one is formula 10. Formula 10, page 60. I've been saying for this case, if at all n is given to you as a negative, then we shall have to use indices and ensure that the n is a positive. Yes. So you should know that this n is also not a fraction. It cannot be a fraction. Should avoid that. It can be x plus 2y over 4, such things. As usual, etc. will always be somewhere. etc. And here, etc. Let me hope that message is for the formula of binomial theorem. And why can't it be a fraction? Yes. If you were here when I was teaching binomial distribution, if you recall, binomial distribution in probability, we saw that we had something to do with combinations, and those same combinations actually come again as you're dealing with binomial theorem. And I remember telling you that for combinations, you can only have a zero and other numbers. You cannot have a fraction. You cannot have a negative. Those who recall. Those who recall. That's why I want to quote the logbook formula, so that when you look at it, because, let me actually put it here, because the formula has or involves combinations. Please, who is telling us the formula for binomial theorem? The one of a plus b power n. It is supposed to be there in the logbook. No one is seeing it. Because formula involves combinations. That's why we are avoiding a negative and also avoiding fractions, because the formula, yes. So we shall say combinations. Now there is someone who doesn't know the meaning of combination. For you, the one you know is the combinations of the subjects done at A level, BCM, PCM. So you are like, what are they meaning here? Which combination? So you recall that combinations of negatives stroke fractions do not exist. Don't exist. Yes, that's why we are like, avoid n. That's why you're saying that n is a 0 and above. When it is a negative, we apply indices and bring back a positive. And it should not be a fraction, because the formula has combinations, and you all know that combinations of fractions of negatives do not actually exist. Thank you, sir. Okay. Abigail, you're not seeing the thing. That is too absurd. Teacher, the one of theorem 8 ain't in the logbook. It is there. It is there. Let me get it here. You're going to confirm with us. Eh? I sent you a logbook one time in the group. So Abigail, you stay on. Those of you who have the logbook, I'm going to send you somewhere. So those with the logbook, you go to page. Those with the logbook, you go to page. Someone has said it is there. It is there, but it is somewhere weird. It is somewhere weird where it is not supposed to be. But it is there. Though for it is in terms of x and y. So for you may be looking for a and b. But it is in form of x and y. But wait. Abigail, let me hope the formula you have given me is correct, because I'm seeing some other method. I'm seeing some other method of on page 62. Oh, by the way, Abigail, the formula you gave me first is for binomial theorem. Then the one of binomial expansion, you go to page 62, formula 48. So it is this one which is actually page 60, formula 10. The one on top. So if you look at that formula, you have combinations somewhere, though you may not be in position to see them. Then for this side, and we don't mind, these things will actually be revised, yeah? Whether by me, whether by your teachers, but one tuli basibira ntanda. Here it is formula 48, page 62. Page formula 48, page 62. So don't worry, here you have a plus bn, but in the book there is x plus y power n, which is the same. I'm saying again formula 52. You people, am I having the one I have is second edition. You people, please correct me. The logbook I have is second edition, yet we are on third. So someone is telling me that the formula is 52. But nah. Yes, teacher, it is 52. Okay. So the other one is the other one remains. Okay, formula 52. So I was using the old edition. That's why I didn't want to use it at first. That is it. Yes, you can see polynomial theorem and expansion. They are also known as a thing. So you should be knowing how all those ones are dealt with. How do they expand? How do they actually deduce? You know those things of deducing. It's where they ask for the deduction. Should also be aware. So with all that, I'm just going to fix something here. I'm going to buy space. I'm going to say formula. I buy more space. People, you buy logbooks. You see, even the logbook I sent you is old. So we have said that this one is the formula 52, page 62. Kategeti. Meaning, another thing you have to know are deductions. Yes. Deductions. Be in position to deal with expanding different cases, being in position to do deduction. So I've told you that the statements that I'm putting here, you have to be serious enough. In that you ask your teacher, you go to a book, a math pamphlet, math clinic, go under a binomial theorem and expansion. You look at the numbers which require different approach. That's what I mean by different cases. Don't do so many numbers that require the same approach. You saw today when we are doing vectors, we're on the same thing, dot product, but we applied a lot of things. You get? So that's what I mean by different cases. I may not list the cases here, but you should be in position to know that this one was obvious, this one has a square root, this one doesn't have a square root. There is when they tell you, hence, do this, something like that. Just because my question bank is very far. But at least I remember some things, some UNEB questions. UNEB 29. Someone tell me whether I'm right. 2019 number 14. Someone tell me, is it about binomial? If it's not about binomial, then I will quit quoting UNEB numbers. It has been long. Someone tell me, is UNEB 2019 number 14 talking about binomial expansion? We're in position to deal with those different cases. Let me see. Yeah. Hey, that means I still recall something about it. So by different cases, I mean, there is that case which will be normal 1 plus x power 5. By the way, you have the cases above, but the cases are there on top. The other case that I want you to see is that one of 2019, where there is a root. By the way, we have it. The cases are just there on top. Where the fraction is a negative, where the power is a negative, where the power is a fraction, where the x term is a fraction, where it is a negative, where it is not x, such things. So I think that summary has it all. That is just the 6th. Remember, there are 9 topics of algebra. We are still struggling. G. What are we going to do for G? Remember, we have more theory. Here, I'm going to put for you complex numbers. Complex numbers also under algebra. Yes. Complex numbers. Complex numbers. These ones, very easy things. Now, what is hard in this topic? So here, remember at first we looked at operation. Please clarify on validity of a binomial expansion. By the way, you add it there. Validity. I told you that's where our ETC comes in. But let me ask, this number 14, does it have validity? Well, can we fix validity? Just fix it here. It is going to fit. ETC, where we talk about validity. Thank you for that use of validity. Very important concept. This one, if they set it, a half of the country can fail it. Validity. Very rare and tricky. Validity. That is also something you have to look at as a student of algebra. Then actually even Yusuf talked about modulus here for inequalities. So as you're also looking at inequalities, don't take modulus for granted, but it is falling under other cases. But I can just try to highlight it. Modulus is also a case. Which cases I briefed you here? That all cases. So the all cases are in touch with this modulus. I told you when I over zoom the screen in, it disturbs a bit. So all cases are in touch with modulus. But it is a very important special case. And they also validity. Now, complex numbers, I've been telling you what we dealt first with was operation. Yes, operation of a complex number. Operation, or what they usually call algebra. But I say that complex numbers are denoted by Z. So when I say Z, just now I mean complex numbers. So operation, they are those ones. Addition, subtraction, division, multiplication. So complex number, the denotation is Z. Or I can use small z. Any is okay. So you should be in the know something about the operation. And the other thing we covered next was forming equations. Forming equations. If you recall. And then obtaining complex roots. By the way, when we are done, when you see me getting done with algebra, just know we are running with only calculus. And if you have been in position to be patient up to this point, sorry, I mean complex roots. Then after that, on complex numbers. Now let me see if people actually be following my lessons. What I've written so far about algebra and that was covered. There is something that we are supposed to cover next. Then I told you that you make research. What was that? What was that thing I told you to make research on that we are covering it next? What was it? People have terms. Agriginad. Agriginad complex. What is that? Agriginad. That is new in the industry. Anyway, I told you in the modulus argument form. In the modulus argument form. That means you need to know about how to get the modulus and the argument. Complex number. I don't know whether people are aware. So you need to know the modulus argument, or what they call polar form of Z. A lot of work is there. And because of that, hence, you should know something about the Argand diagram. Yes. Should also be aware about the application. About the application of polar form. Big you to get the third root, this complex number. Very easy things. Should be also aware what they call de Moivre theorem. Yes, de Moivre's theorem and many others, etc. The other things we covered, like square root, that I'm not talking about. Yes, but those ones, of course, under application we can see them. Eh? But a lot is coming in the etc part. So even here under algebra, you should not take lightly things like finding where those techniques were taught. Plus, but you thank God, tomorrow the overnight of chemistry, I briefed you, you have the facilitation, we even have a recording. That I'm not going to say a lot. That one you should be knowing everything. Yes, everything. You must be knowing the content. Yeah, that one we are going to just start straight away. Content. But this math, I want you to leave this session when you have a plan. Hey, let me see if people even still 30. Hey, I just want to be with 30 people up to when I finish. Our first break is going to be at midnight. So let me hope people have already had supper. You have to eat. You have to eat as you're listening. That is it. Hey, Gary. Do you know what they call completing? Do you know what they call leaving a session when you have plan of a paper? So when you combine the plan of paper 2 and the plan of paper 1, all I'll be waiting for is the distinction. Chemistry, that one I will handle. Even we kwase Kyagulanyi. All we need is life and grace. Shall be there. Kali. G is the 7th. That means we have more 2 algebra topics are 9. What do we have in H? Most people know permutations and combinations. That one is going to come last. It is the I, the 9th. So someone tell me, what do you think? What do you think is that 8th before permutations and combinations? For you, what do you think? Polynomials. Polynomials. I don't know. I forgot these ones. They had to come earlier now. I'm not serious. I'm not serious at all. Thing had to come first. That come after quadratics. This one was taught the other holiday, first term holiday. So we have operation also. Yes, we have operation, what you can just call algebra. Yes. And it is in this algebra where we find those concepts of long division. So where we find concept of factorizing and etc. Then we have factor theorem. Factor theorem. Let me see if I recall some numbers. Someone who has a question bank, please. You be with me. I don't want to put something wrong. What I recall, factor theorem 2016. Of course, we are dealing with paper 1. Number, you check somewhere there, number 4 or number 5. Number 4, number 5. There is a question that was talking about common factor. You check for me. Then for remainder theorem, 2020, number 9. I don't want to put something wrong. Please, you tell me early now. Then 2016, 20, I think, yeah, 2016. Is it there? It was a number talking about common factor. They gave you 3 equations. They told you that they share a factor. They are there in the middle, but section A, number 4, number 5. Then remainder theorem. Let me see. Win is saying number 5. That means I'm right. Number 5. Then you go to 2020. Is remainder theorem number 9? Where they gave you remainders. That this divided by this remainder is this. I lost my QB and these people checking for me are a bit slow. Okay, somebody else said yes. That means the examples are already there. Because someone may be like, what is factor theorem? What is remainder theorem? So you refer to those numbers. And that's how easy polynomials are. You know, operation where you find long division. So the last one are what we call permutations. Yes, permutations and combinations. So you should just know that combinations, you write them like this, maybe 4 combination 1, permutations, 4 permutation 2. And the other thing you need to know that permutations are the arrangements. Combinations are selections. For me, I used to confuse my classmates. After making my research, I tell someone, what are the topics under algebra in your school? Someone mentions permutations and combinations. Then I tell them, did you cover? They say yes. After saying yes, I ask them, did you cover arrangements and selections? They say no. I laugh. I laugh at them. You talk to your friends, your village mates. You ask them, did you cover permutations and combinations? You only look for those ones who are going to say yes. So that after they say yes, you ask them, did you cover arrangements and selections? They will say no, or they will tell you, ogamba binene ebya GP ne AP. So that is it. So I'm going to put for you 2 notes that actually confuse people. 2 of them. 2 notes. Note. There are these 2 things that people actually put under algebra. Note. Let me see what people are saying. Combinations can also apply probability, please. Yes, because we used them in binomial distribution. Those people who are attending. Hope you recall, yeah? So what do I have to note? To note that sometimes there is what they call partial fractions. Yeah, partial fractions. Most people, most cases want to put them under algebra. But these ones are going to be pushed. They are going to be pushed to integration of partial fractions. The problem is one. Today I wanted to teach. I had 3 things and I had to pick 2. And those 2 I had to cover them up to my target. I had in my head I had vectors, I had complex numbers and integration. Integration was a must, so I was like, should I pick vectors or complex numbers? The problem is they are the ones I want to cover after this. But again, people claim that they will be tired, forgetting that we are recording. So you will attend as you are tired and dozing just to get the blessing. So these ones, we shall get them under calculus because of integration. After getting the blessing as you doze, then you wait for the recording. Then you will depend on the recording maybe. Yes. Then the other note is that we have something else they call Maclaurin expansion. Maclaurin. So someone may come and tell you, but your algebra is lacking Maclaurin. It is not authentic. You tell them Maclaurin expansion is an application of differentiation. So for even if it is an expansion, I'll push it to analysis. So this is an application. Whether you people, the other thing I forgot to tell you that calculus is the same as analysis. Application of differentiation. So because it is an application of differentiation, this one we are pushing it to analysis. Pushing it to analysis or calculus. And just like that, that will be the end of algebra. Algebra. How do you fail math? End of algebra. The other thing I forgot, I was saying that calculus is the same as analysis. So I'll come here, just fix it here. Just some simple one. Analysis. Yes, analysis, all calculus. So if you're there and you are this student who crashes on algebra, my dear, have three pages. Three pages. They cannot even fit. I cannot even pinch all of them. But you can see. And I'm trying to actually break them down for you so that you recall these things. So I want someone, I want to talk about the Maclaurin, because partial fractions, I believe you have heard of them. Maclaurin, you go to the logbook. By the way, when I say formula 10, I mean logbook. So someone go page 62. Page 62, which formula is Maclaurin? Page 62. You be fast. I remember seeing it on page 62. So you be fast and tell me, where are you seeing the word Maclaurin? But are you seeing it anyway? Is the word Maclaurin anyway? Okay, that formula where you're seeing log E or lean. It is either log to base E or lean. Which formula is it? Is it 51? Yes. We are looking for the word Maclaurin, but they couldn't see. The moment I mentioned the logo E, page 62. So that you have a beginning. So just know that is what you need to get 68%. The moment you cover the first 6 of algebra, last year UNEB said permutations and combinations. The very thing that people leave out. UNEB is funny. I always tell you, what you leave out is what UNEB said. Let me tell you, people knew algebra. Are you saying whatever I've mentioned? People knew algebra. All algebra that is on the first 2 pages and a half. You get? People knew indices, people knew roots, people knew polynomials, people knew equations, people knew series, people knew binomial. People left out permutations and combinations. You never said that's what we are setting next. So here under series, I only talked about AP and GP, but there is what we call proof by induction. Those questions are always clear. They tell you direct. Proof by induction. This one I have my reference. There are references I trust where I don't even need you to check. So there is what we call proof by induction. Proof by induction. It is this is your neighbor, of course. Here we don't deal with local bodies. 2020, 2023, number 1. 2023, number 1. That one is obvious. By the way, you people, hey, I'm worried. I want to find out how to keep these recordings. Zoom is very expensive for a year. Me, actually, I thought it is something like $1 million, but it is even more than $1 million. Because on top of subscribing for the licensed Zoom, you have to buy space for keeping those cloudy recordings. It is something clocking 2.5 M for the year. So just use these recordings so well before you go back to school. What we can keep at these workbooks, these ones are already available. But I'm worried because I'm looking at keeping these recordings and you're going to be at school for 2nd term and 3rd term. That will be a wastage. So just make sure you use these recordings well. You refuse to bring clients to pay, we pay the Zoom for the year so that the recordings are available. But Zoom may delete them because it is expensive and also I may pay for nothing. But the workbooks, they will be available. So recordings, just make sure you use them well for the remaining time you have before you go back to school. That's what I've told you. Don't say I didn't. Thanks, sir, but I failed to understand proof by induction for trig. So you quote that, and that one you fail to understand. That's what UNEB is going to set. Yeah. But don't worry, we are still together. We shall handle. Yeah, we shall handle. Kali. So before I go to the 4th, which is calculus, this one is not even worded. This one I've taught you myself. I taught you differentiation myself. I taught you what? I taught you integration. I've been teaching you integration myself. This one I'm not going to say a lot of words. I'm going to just give you the first break. Don't go off. But before you go for the break, you stay on. Don't log off. And the break is just 5 minutes. And during that break, there are people who are sober. You stay on and ask me. Ask me what you want. But before you go for the break, recall that calculus is 3A and 3B. 3A, those are 3 questions each carrying 5 marks, making it 15 marks. For B, there are 3 questions each carrying 12 marks, making them 30 what? 36. So when you add 15 to 36, you get 51%. I enjoyed this paper. At UNEB, I got 98. Those who know my teacher, you are aware that I'm not telling lies. For me, I passed this paper. I got 98. Because after looking at calculus as as 51, that is half the marks. I handled the whole of calculus. Every paper we could do, calculus 51. Every paper, calculus 51. I did a lot of questions on calculus. Someone is like, how do you know your marks of your name? You simply be connected. Oh, see these marks because we put our names. And by those days when we used to study, we were academic celebrities. So knowing my mark was something next to obvious. 51%. So I'm going to give you just a break of 5 minutes. As you think about this, we break down calculus. I tell you what we are going to do for geometry. We pick those papers, we go through, like, we are going to go through 5 papers only. A UNEB paper, a mock paper, from like 2 UNEB papers, no, 3 UNEB papers, yeah, and 2 UNEB papers and 3 mock ones. The rest, it will be your work. Then we come back. I give you another break, then we come back and see what we can basically cover. Because we have more, it is just 16 minutes past 11 p.m. That means we have more 5 hours and 44 minutes. Hey, hiya bus. So those who have questions, you can ask. Those who want to have the break, you have the break for just 5 minutes. So at exactly 21 minutes past 11, I'm starting on the breakdown of calculus. Do you know what it means to break down 51%? It is worth a breakfast. Those who have questions, you ask. Someone is telling me to expose for them F and H. There we go. The one who wants F and H. Someone is asking, is it true that no, the constant is never affected by anything? You just write the constant as Lindsay, period. Don't overthink about that. They are lying. You tell them Paul tutor said no. Now, why did the people log off? So rate of change in differentiation 1. Yeah, those are the things I'm mentioning next. Don't worry, Yusuf. So those of you who have stayed on, you take this screenshot, tell your friends we have started again. Tell your friends in the group that we have started again. Let them log on. Take that screenshot, tell them we have started. Let them come. We proceed. We have more 5 hours. Hey, they play. Nigerians say they play. Okay. Danny has said we are back. Okay, let me hope so. Now, calculus analysis. You learn this. T. No? It's divided into 3. What they call differentiation. The differentiation is also divided. They call differentiation 1. So the question should be Charles is also divided into its application, what I can call application of differentiation. Then it is also having what we're calling further differentiation. If I mean differentiation. Then the same calculus has what we may call integration. So I'll come here. I want you to appreciate that even in integration, we have what I may call integration 1, just like differentiation. Then we may also have let me put it on top. You people, thank you for coming back. I didn't know that people were going to come back. So I was saying that we have integration 1. So people are interested in the 51%. We have what we call integration 1. And as usual, just like differentiation, we also have further integration. Yeah. Then we also have the last part. The last part, which I'm also going to talk about, that I'll talk about later. That one is called differential equation, what people call DEs. We're also going to talk about them. Yes. Further integration shall begin from there. Further integration shall begin our summary from there like that. In integration 1, also have our summary from there. Then further differentiation, we shall have our work there. In application, we shall also have our work there. Yeah. Then differentiation 1, we shall put it this side. Integration 1, put it there. Something like that. That summary will work. Yes, this will try to bring out the part A of calculus, the part B of calculus, then I'll bring the part C. Hope people are ready for the breakdown. Said differentiation is part A. Part A. Integration is part B. We shall also see part C. So the question is, so in whatever you're doing, every time you be like, I'm a student who is supposed to do calculus, differentiation in particular, ask yourself, am I okay with differentiation 1? So the thing is, what is in differentiation 1 that you know? What is in differentiation 1 that you are aware of? First things first. Because without what is in differentiation 1, even if you know further differentiation and its application, UNEB will disappoint you by setting diff 1 which you are not well conversant with. So you have to ask yourself, what is in this differentiation 1 that I'm supposed to know? So according to our arrow, you can see that that box I've drawn is going to have the content of differentiation 1. I don't know if people can actually see that. So that's where we are going to put the content of differentiation 1. Now, what I told you the other time was what we call further diff. There is application which I didn't talk about. You understand? That one I did not talk about it. I cannot lie. Then there is the introduction, which I actually skip, sorry. Even on integration 1, you're going to see there are things I skipped. Still, what I was teaching you was further integration, as we are going to see. So in differentiation 1, there are those things that actually they teach first. They are too friendly. Those things of curve sketching, you understand, gradient of a curve, all those. You may take them to be as diff 1 because they are just fine. Where you even talk about velocity and acceleration, those things. So actually here in diff 1, no, this is where we actually teach gradient that's where we teach gradient stroke equation of a curve. Yes, very important. In differentiation 1, this is where we actually come talk about curve sketching. Curve sketching in diff 1, in diff 1 that we actually teach the basic rule. Yes, and remind us about the basic rule. It says every time you are differentiating a function with respect to x, what we do is we drop the power and then we reduce the power by 1. So it is still in diff 1 where we teach the basic rule. Yes, we talk about curve sketching, then gradient stroke equation of a curve. All that in diff 1. Then we have the application of differentiation. Here in application, this is where we talk about the maximum. This is where we talk about the maximum is where we talk about the maximum stroke minimum. The function. So when you see any question talking of those things, rates of change, I think 2024, number 2. Let me check whether you all have that paper. I think I even sent it in the groups. Just this year, 2024. Let me check. 2024. Yes. Oh, that one is for again for minimum value. That one is for minimum value. So if you want a reference for this minimum and maximum value, it is 2024, number 2. Yes. And the good thing, these ones of rates of change, those ones are easy to tell, yeah? You always see that word rate. This word rate will always come through. Then lastly, small changes. And I think this same year, it is in that same year where we have small changes. You people, let me tell you, this breakdown is so important. That same year, you look at that paper. I think it is number. I remember seeing it somewhere. Oh, I think it was in the other section. Let me see. It was number 13, part B. Yeah, but the same paper. 2024. Even this question, the same thing. The question will always tell you using small what? Small changes. These questions are nice. The question will always mention the word rate if they want you to use rates. The question will always mention small changes if it wants you to use that. The question will always say maximum or minimum, or it will just say like that here. They say to minimize, and the other time they will say to maximize. So those words will always come through in the question. So you'll be advised accordingly. You understand? So you see, a student who has biased, imagine a student who has bias about application of differentiation. For them, they say, good thing I know basic differentiation, the good thing I know curve sketching. Now, the moderator concentrated on application of differentiation. And that's how the students maybe got stopped out. So it's a bit funny. Yeah, it's a bit funny. That's what I say, that if you say that you're a student of calculus, make sure everything is in the know. Make sure you know everything under calculus. Otherwise, you never end up picking what you don't know. Hey. So in further differentiation, what is actually done? This is what I taught last holiday. We did a lot: implicit functions, explicit functions, parametric, composite, trigonometric, algebraic, exponential, natural log, all that. I don't know if people can actually recall that we did all that work. Do people recall that all that work was done? I don't know. Can no longer access those recordings, but sure, I had to show you some. Okay, so these ones I said we are going to try it here first. Now, algebraic, purely now for this case, composite. So in this further differentiation, I was teaching you differentiation of the different functions, and it's what I'm going to actually say again. We were differentiating different functions with respect to x. We are differentiating different functions with respect to x. What were those functions? They are the composite functions. Because someone may be like, so this is what is under this side. We have explicit functions. It is up to you to go back and revise what are the explicit ones. So you don't cram these things. Implicit functions. Implicit functions. We have trig functions. Told you when I over zoom in, the screen is a bit slow. You should just bear with that. We have the trig functions. Just use f of x. Then we have the inverse trig. Remember, we are working on 51%, so don't get tired. Hey. Inverse trig. We have the exponential functions. Have the natural log. We have those that can be in terms of log. Apart from natural log, we have those that can be in log. Exponential, implicit, explicit. So question is, which other ones I've not talked about to see if actually people recall? Let me pinch for you a bit. You have the composite, explicit, trig, inverse trig, exponential, natural log, log itself. Which other one was differentiated? you have to know that the other important things that were done. We have the product rule, if people recall that. Product rule, quotient, chain rule, that is it. Yes, that's all you need. Of course, you very well know that it is under chain rule that you can find that rule they name as power bracket, which is a shortcut for chain rule. That one shouldn't bother you. So that differentiation that you have not covered, or that is giving you hard time, that is actually, that is basically, let me even pinch for you. That is basically what you need on differentiation. Basically that. Basically that. The application, there it is. Diff 1, there we go. Integration, we have integration 1 and further integration. Further integration is what we have been doing. Integration 1, we are going to just see the things that actually fall under integration 1. Yes, such that if you want to fully cover it, just add them on your own. But for us, we are still proceeding. Yes, we are still proceeding with further integration. Don't judge. There are people who are good at judging. They be like, now why haven't you been covering? Why didn't you cover integration 1 first before further? Question is, what aren't you understanding that required us to do integration 1 first? Yes. So in integration 1, there are some funny concepts that you need actually ideas on. Yeah. But some even talked about them briefly. Briefly, not so much. We have integration 1. I told you that actually this thing is like differentiation. It has integration 1, it has the application, and the further. So in integration 1 here, they basically look at the definite, and indefinite. Definite and indefinite integrals. Then that is it, of which we talked about them. Then this integration has applications. So I will say application. Application of integration. So here, yes, we have some funny concepts. Under the application, we have what we call area and a curve. We have volumes of revolution. Only those three. This is where we apply integration, as we are getting area and a curve. Also have volumes of what they call solids of revolution. Solids of revolution. Then lastly, the things we haven't covered, but you need them. But they are not hard at all. Then lastly is what they call mean value of a function. Mean value of a function. Yes. So you go to your teacher and be like, sir, how do they say it about the mean value of a function? Not that you crammed it, but you've just checked on it and realize it is something you're lacking as far as integration is concerned. So you go and ask your teacher, how do they set these questions of mean value of a function? I want to try some. Yes. Yes. Then what we have been doing, I said it has been further integration there. Yes. And it is this further integration that actually talks about the 16 methodologies. Yeah, that's the further integration. The one that actually breaks down the other methods. Oh, the other methods, the 16. I don't know how many we have covered so far, but the methods, have it at the back of your mind. They are 16. Hey, maybe we need to mention some and see. So we have integration, first and foremost. Have where we use change of variable. Change of variable. Then we have where we have a function and its derivative. So I will say existence of a function and its own derivative, or just and its derivative. Have integration integrating trig functions. Yes, now we know that for trig functions it's a bit technical. How? The trig functions will have somewhere where you need to use factor formula, as we saw, actually expansion formula. Then there is odd power rule. There is where I deal with odd powers. And of course, there is where we deal with even powers. This one people are aware. So those are trig functions. Then is integrating exponential functions. Is integrating natural log functions. It tells, I think let me close here then. We are integrating all those. I'm assuming that we are integrating them with respect to x. I'm listing others. X. Still on further trig. Sorry, still on further integration. So I'm going to put another arrow here. Here. You have sine and tan substitution. Still coming. Integrating using sine substitution. Tan substitution. There is scalars. The scalars are the other ones. Maybe you integrate there is integration of partial fractions. Let me begin with by parts. That one is most important. By parts is different from integration of partial fractions. It's called integration by parts. The other one is integrating partial fractions. Well, the methods are 16. So we have to count them after and see how many are they and how many we have done. Integration of partial fractions. Still going. Have the one of splitting. Have the one of splitting. I don't know whether people, I don't know, is this person calling till this time? How can you call me at least? Anyway, so we talk about splitting numerator. Yes, splitting numerator. So when you may need to split the denominator. Yes. So people, you count for me. How many are those methods? Hey, may I told you midnight people are going to be tired. Take substitution, that one you leave it. So how many methods are those? So it is dealing with log itself, f of x. Let me first stop here. Then I put dx. So strict functions. So I had to begin with the composite ones. Because composite functions are the easiest. Composite ones are these ones of x power 4 plus 2x power 3. You get? I don't know if people know inverse trig. Inverse trig, like they can tell you to integrate the inverse of sine x. X dx. Yes, like that. Then I want to put here part C. Don't want to waste time. Same page. I want to put part C of calculus. Part C of calculus is what they call differential equations. Not easy to design this work, but I told you stay on, we are going to design it together because you are also recording and we are done. Calculus, I told you, it is the most disturbing. Yes, differential equations. Members disappeared. We don't know why. But not even 25. People are even dozing off. So for the ease, this one should not stress you. For now, because even what you need is very simple. All you need is solving the different kinds of the ease. That is one. That's what you need to know first. Roman 1 about the ease. Be in position to solve all kinds. Then Roman 2. Then Roman 2. Then Roman 2 should be in position to handle the application of the ease. After here, we are now going to the question papers. We look at paper per paper. Paper, I told you when I zoom in, yes, it becomes so hard, yes, for the screen to actually handle the application. I don't know. Is there anyone still on that can find 2023 paper 1? Is there anyone who can find it? Screen is becoming hard. And application of the ease. Yusuf, 2023 paper 1, you tell me, is number 16 about the ease? Because I want to use examples of the most recent years. Number 16 is about the ease, isn't it? Anyway, the good thing, we are going to zoom out. So our network is going to become okay. Now, why are you saying a minute? I thought the paper is there already. So the other cheat code I want to give you, the cheat code is that this is usually number 16, just like if you check 2024, it is number 16. So usually this is the last thing that is studied in calculus. So even as those people are setting, they always prefer to put it last. And I don't know why they always like to put it last. So I'm saying it is usually number 16, just like number 16 exactly. So just like 20, 23 and 2024. So Yusuf has confirmed that 2023, it was also number 16. Even the paper that we have of 2024, it is also number 16. So in most cases about temperature changes, those are the ease. So if you even check that paper, even check that paper of math. Hey, people disappeared. It was also number 16 last year. You can see Pate was saying form a differential equation. So since it is something that is always handled last, yeah, that's what they always do. So this one, we also mark the end. So I'll come here and say end of calculus. Even have the cheat code that the E's are always on number 16 because they are handled last. So end of calculus. End of calculus. Yes. So we have tried to fix our calculus on one page. Yes. Wow. Wow. Yeah. Whatever you're seeing there is 51 marks. Whatever you're seeing there is 51 marks. So just concentrate on that page this holiday. Make sure by the time the holiday ends, the page is just ticked everywhere. That means by the time you go back to school, just practice your calculus and your algebra. That is already 85. So make sure as you are planning to be a verified student of calculus, make sure those three are on your fingertips. 1 is differentiation, 2 is integration, 3 is differential equations, and each is divided. Differentiation and integration are divided into 3 common subcategories. What are those? Differentiation 1, integration 1. Application of diff, application of integration. Further differentiation, further integration. You understand? E. Then lastly, differential equations. How do they do them? They solve and deform. Then you also handle the application. And these are usually number 16. Just like you can see in the most 2 previous years. That's what happens. So 2 things I've not mentioned that I'm going to add right now. Then we go to papers. So when you go to papers, just get ready to tell me that this one is belonging here, this one is belonging here, like that. So here I've said we are solving and forming. So here I've said solving and forming. Hey, people are going to ask you tomorrow, hey, you people, what time did you end? People are going to wake up tomorrow morning at 8 a.m. They're going to send you messages. Hey, you people, at what time did you end? Yet we are still having the lesson because I've now pushed the time to 10 a.m. So your friends will wake up at 10 and they'll be like, hey, you people ended at what time? Then you tell them we are still having our lesson. Okay. Now here is where I also teach the basic rule. Yes. The basic rule is taught under integration 1. Just like the basic rule of differentiation is taught in diff 1. So I'll say basic rule, and what is the basic rule? Should be aware that when you integrate x power n dx, I increase the power by 1, I divide by the new power, And I make sure that I should not forget the constant of integration. Those are now obvious things. I've liked this summary. I'm going to print it out and pin it somewhere. It is actually having everything as far as the 51% is concerned. Yeah, it is just having everything. So we are now going to go to question papers. Paper now 20, paper reducing slowly by slowly. Let me see if my paper is still on. So you go to the papers, we are going to begin with the UNEB paper. Yes, we are going to begin with the UNEB paper of last year, 2024. 2024. So this is where we are. That's what we are looking for only. We are going to be following that order up to calculus. So I'm sending the paper in the discussion group. Yes, I'm sending the paper in the discussion group. So I've sent the paper, then we're also going to use the other papers that Carlton sent. I also sent some past papers, but let us begin with that. We're going to begin with that, then that. After we go through those that Carlton sent. So when you go to paper 1, trigonometry, which number is it? Now I want to see if people are not dozing. Trigonometry, I want some bold person who has opened the document. We go through it together. You raise up your hand, you unmute, I ask you trigonometry, which one is the section A number? You tell me that this. We go to section B, you tell me the number of trig, we leave that. We go to vectors, you tell me which number, section A. For me, I will be telling you the section where the number is falling. And unfortunately, people have left at a point where they are needed the most. This is where I need you people the most. I don't know if someone has the paper of 2023. They should actually send it in the discussion group. Hi, Jeffa, you're going to come on the next paper. Melody, you are the one who is going to begin. Ladies first. Then I, Jeffa, you're going to come on the next paper. So Melody, let me ask you to unmute. You unmute. We are following that order. So trigonometry, which number is the section? Where is the section A number?
The first paper, the first paper, trig is a number 6.
Number?
6.
In section A, then in section B?
Number 9.
Let me check.
Number 9.
Yes, as you get prepared for vectors, I'm going to check. You first follow these. How can people go off the point where you need it? Okay, so you are saying those people who are on, have you seen the papers? Or you want me to share the paper here on Zoom? Actually, I think let me do that. I think sharing the paper on Zoom will be better, isn't it? Because some people claim that it is hard for them. Hey, it's better. Okay, let me do that now. Okay. So Melody said that number. So Melody said that this number is 3. That one I see. 3. Okay. Then she's saying number 9 is 3. Yeah, I think you've seen. So that means, so to talk about them, this is show that the proof part which I talked about. So that means it wasn't a lie. So some people are back, at least I'm happy. 25 people are enough to reach 5 a.m. Yeah, those ones will be enough. 25. Every time you see one number reducing, you call one more person. So this is the number of proof. I think that one is okay. The number 9, if you look at number 9, it was of R formula, which was also mentioned. Then and part B is asking the maximum and minimum, which is also part of R formula. Then solving equations, which was also mentioned. Something like that. Very easy. That is trig. 1A and 1B. Melody. Section A, there it is. Where is the number of vectors? Where is the number of vectors?
Number 7.
Number 7 is here. And this is what they call the ratio theorem, because we actually seeing the ratio. And remember I mentioned the ratio theorem. So that one vectors confirm. Then which number of vectors is in section B? There is section B.
Number 15.
Number 15. Because the words are actually there. If you look at number 15, words that were mentioned, we have there words that we actually mentioned. And what were those words? You can see. This is what they call the Cartesian equation. You can see plane. We talked about properties of perpendicular. Point lies on the plane. We talked about coplanar. You understand? We talked of point of intersection. We talked of perpendicular. Now this is a very easy question. I told someone actually read the breakdown. Number 15. I'm doing this so that you people be strong. But every time you hear me saying that I'm going to do vectors and you are strong. You understand? You are strong, but at least I'm securing a number. So vectors also secure A and B. Now we go to algebra section A. Where are those two numbers of algebra in section A? But
Number
for
1.
I want to add on something here under vectors. But for vectors here, for this part of ratio theorem, we should note that this part of ratio theorem, we should talk about the internal. There is internal and external. There's when we say divides the line externally. You understand? There's when we say divides the line internally, but we shall see. I didn't want to talk about it because I've not yet. But when we talk about ratio theorem, that was we'll go. What are those two questions of algebra melody?
Number one.
Number one, what is it about? You can see. So if I may ask, is that a permutation or a combination? Melody.
Yes. That, uh,
It's a combination because they are using the word selected, isn't it? You
yes.
said combinations are selections and arrangements are the ones we call permutation. So this is a combination. Okay, so we are having that one of a word. Which is the other question of algebra?
It is number five.
Number five. And number five, we are seeing there the word metric progression. And we are seeing application. So this one was also talked about because we said it's application in ABC. So algebra, we are seeing now the second question of algebra is the keyword. Then we go to this section. What are those two questions of algebra? What is the first one?
Number 10.
Number 10, given that the polynomial is divisible, I think you can see they combine polynomial and inequality. And the sign they are using is this. That is it. So you know that algebra, they can pick anything. So this is one of algebra. The algebra. Another one. I used to try to finish. Any other? This one is good. I get you get it. Melody.
Yes, it is.
You are not seeing it.
Is it number 13? Number. Hmm? Number 14.
Number 14. Because you're seeing that here they are talking of a complex number. And even here they're asking you square root of a complex number. This one was mentioned. Square root. It was mentioned clearly.
Yes.
Then this is under algebra of complex number. You can see these things we taught them in the most previous lesson. Square root of a complex number. You look at the marks. 7 of them. I always tell you that the moment I cover something and it is a UNEB question, I consider that as a super. Those are 7 marks of something that was. This is the second name of algebra. So algebra in section B is just okay. Now we go to curriculum. There is section A. Where are those questions of curriculum? Where are they?
Number 4.
Number 4, yes, because it is integration. Melody, which other number? This one was taken.
I don't know.
You don't know.
Yes.
Remember, I talked about this. Are you seeing what they are saying? Find the value of x that will minimize the area. So they are looking at the minimum value. This is application of differentiation. That is calculus. You understand?
Yes.
Yes, this was algebra. It was taken. Then when you come to this number, they are saying area enclosed by the curve. That is area and a curve. That is application of integration. Just look at our workbook there. Here at the end. Just look at that. Do you see that under differentiation, we have something that says under application of differentiation. Are you seeing something that is saying minimum or maximum value?
Yes.
That is the number 2. Then for integration, you check under its application. Do you see the first arrow, which is saying area and a curve?
Yes.
Exactly. That is this number 8. Area enclosed by. Hmm. Then we go. So those are this one is just integral. This one is just integral. This one is direct. Very easy. Now, this one is geometry. Which I'm going to briefly about. Lastly, when I don't want to over talk about geometry, I'll give you the reason. That is geometry. Even now we go to this one. Let me take you through very fast. You can even see they are integrating, here they are depreciating. So that is calculus. That is the first question of which they're supposed to be three. Proceed. And you see this very fine. Maclaurin, I told you it is an application of depreciation. This is mold change is another application of depreciation. You see a full question concerning only application. That is another question of calculus. So those are two. Then finally, this last number 16, talking of forming a differential equation, which we saw as parts under calculus. And this is the easiest number. These are the easiest things on earth. I don't know why these are even done now, but you cannot actually understand them if you don't know it. They are the easiest thing that you did with only one form. So this is also calculus, the third question. Melody, have you seen that?
Yes.
Yeah. So I'm going to give you people time. I'm going to give you people time. You can read this thing again. That thing of identifying numbers and be like, this number is coming here, this number is coming here. It is so good. That's why I always want us to derive these things together. Not people go off because of reasons they don't know, but it is just wide if we break these things down together. As you're going through a paper and be like, this one is going here, this one, you print a lot of paper, then break them down. You on the paper and be like, this one is coming, this number is this. It is healthy. Chemically, you be aware. Don't say I didn't tell you. I think you've seen that. Now that number, which is the balance, this number, this one, 12, is just joining. I'm going to tell you what we are going to do. I won't tell you about it last. That's why after talking about my target, we went to the papers. So that is the representative of the UNEB papers. And let me hope you're not confused about the identification. I've tried to brief you. I've tried to brief you on everything. Yeah. So we are now going to deal with the mock paper. Only one mock paper. So we are going to test only two papers. So I'm sending the mock paper now in the now the one we are going to use. We still have time. We have more 4 hours and some minutes. Let me get one. Let me get this paper. Very hard. This small body sets very hard paper. So have you seen that paper I've just sent? We're going to try and see whether it is. And most of these things we have done. That's why I'm very happy. So let me share that Kawakata paper. Let me first share it on my PC, get it there and then. So that may have good network. I don't need much time to actually share a document. Already here. So Jeffer, you raise up your hand. Unmute. This Wakata is going to represent all other Moko body. Last year's papers represented all UNEB papers. Jeffer, where are you? Okay. You unmute. Okay. That is section A. You're now going to go slowly. You're not going to over scroll. Which one is the number of trigonometry?
Trigonometry, number 2.
Number 2, trig. It is supposed to be 1. Number of vectors?
Vector. Number 4.
Number 4, you can see position vectors. They're asking for area of a triangle, which we did today. So you people should even go and do this paper because it is fun. Number 1 was complex numbers, which we did. Number 4, area of a triangle, which was done today. Number 6, turn substitution, which was taught. Hey. Okay. Number 3 is differentiation, which was taught. Number 7 is GP. I don't know whether GP or AP, which I taught last holiday. Number 8 is DE, which you are supposed to learn last. Number 5 is geometry, which I'm going to advise you on, which means everything has been done. You people, you're just ready for the D2, but not yet ready for the D1. And you know that our target is the D2. Carry. Questions for algebra. Which number and which number?
Algebra. Number 7.
Number 7 is algebra. Yes, because of the word certain progression. So you know that we are under now series. Which other number? They are supposed to be 2.
Number 1.
Number 1, because they're asking square root of a complex number. Then we go to calculus. They are supposed to be 3.
Number 3.
Number 3, because they're actually talking about dy dx, or what we call the second derivative. So that is calculus. The second,
Number 6.
number 6, because they are asking integration, even by substitution. It is calculus integration. This has been calculus differentiation. Then number, which other one?
Number 8.
Number 8. So you see that this paper was actually so fair. It brought the 3 breakdowns of integration: differentiation, integration, differential equation in order. Then this odd man out is geometry, which I have not yet talked about, and I'm going to advise you about. So you see that one. For this one, for section B, we are going to go number per number. So number 9 is falling under what?
Algebra.
Algebra, because they are complex numbers, not so?
Yes.
So it is a question of algebra. So algebra, the one is secured. They are supposed to be 2. We go to number 10. Number 10, where do you take it?
Caritas.
Calculus, because they're actually asking second derivative, first derivative. So here they're asking diff. Which diff is falling under calculus? That is calculus 1. Even this one is algebra 1. We need more 2 for calculus and 1 more for algebra. Number 11. Where is number 11?
Vectors.
Yes, number 11 is falling under vectors. Why? You see, they are talking of position vectors. They are talking of ratio theorem. They are talking of equation of a plane, which I told you about. They're asking for the angle between a line and a plane, which I told you under relationships. Yes, I told you that yesterday night, because this is today morning. That is vectors. So this is vectors. Vectors 1, that is secured. Number 12.
Algebra.
Algebra, because they are giving you a binomial expansion and another expansion, but they want us to use Maclaurin. This is what I told you, that sometimes Maclaurin is put under algebra because of the word expansion. But since we use differentiation, someone may say, let me put it under diff. So anyhow, and I want to teach you Maclaurin because it is so common. It is in this mock paper. It was in UNEB. It came in 2023. It came back in 2024. It's now here in mocks. And it is very easy. But you look at the marks, 7 of them. So this one is also secured, and it is algebra 2. So algebra is now okay. Now 13. 13.
13, it's differentiation.
Differentiation, because we talked about curve sketching, isn't it? So this is
Yes.
calculus 2. So we have 1 more for calculus to go. Number 14, which one? Where do you put number 14?
Trigonometry.
Trig, purely trig, because they are telling you to show that, to prove these are things I told you. Then solving, you are aware of that. So your role is to just make sure you've done a lot of proofs, you've done a lot of solving, something like that. Then you look at 16. They are saying you write a differential equation. Solve it. I've told you we solve and form. Then further application. How to handle the applications is this last part. And I told you it is usually number 16. You realize even in the mock-up paper, it is also number 16. So if UNEB is to set a DE, in most cases it looks at number 16. So this chi residue, the chi left over, is a chi number from geometry that I'm going to advise you about. Okay. So with the 2 random mock-up papers, at your own pace, so in your own lane. Now, Jeffa, thank you, can unmute. In your own timing, in your own lane, you can now look through other papers and see actually whether that thing is coming out or actually working out. But even this leftover, this one, number 5, I told you it was geometry. So, I think you have appreciated. All other standard papers are like as I said. Just don't be confused at all. Just don't be confused at all. So, you listen. We are done with looking through the paper. Now, I want to tell you about geometry. Lastly, that is 5. And as I talk about geometry, I'm going to tell you that geometry, which is 1A and 1B, geometry is our dynamics of paper 2. Those who recall the paper 2 facilitation. Who recalls what I said? Hey, this one I'm going to be a dictator. This one I'm going to be a dictator. So this number, this one question of section B, leave it alone. Leave it alone. Remember, questions in section B are 8. So when you leave this one of geometry alone, you have 7. Have 7 choices. Have 7 choices. If you have 7 choices, even when you're bewitched, you can't fail. You can't fail to pick. You can't fail to pick 5 and maximize 4. You can't fail to pick 5 and maximize how many? 4. If you have practiced. You understand? Hey, and I always tell you that here it is 4 times 12, 48. Hey. Then sacrifice the 1A. Sacrifice that one question. You get? That means you have 7 of them. 7 balance. 7 of them, which is the balance. Seven times 5 give us 35. This 35, we always remove 13% errors, you all know. And that's what we are working for. A D2. I told you that we don't need 100%. Actually, I told you that this one, and I'm looking at someone who has picked 5. So when you pick 5, that is 5 times 12 to give us 60. 60 minus 12% errors. I think it is the same as maximizing the 4 and get 48. Yes, the same thing. So you people, What is in this geometry? This geometry have locus. Each locus, there is a line. Circle. Parabola. You have the ellipse. You have those ones. These ones, ignore them. Ignore them. Ignore them for my sake. Ignore them for my sake. At your level. The end. So, I'm saying this one, you ignore them for me to your level. But since I've said that they are dynamic, they are the dynamics of paper to just like dynamics, I can re-advise and say you can work on section A questions after perfecting the first four. After perfecting the first four. That is it. You can, if you feel like the load work is too much, teacher, which topic are circles? I think I've answered you. You people, if you think that the question, what if someone does technical drawing, should you so ignore them? You ignore. But I've not seen these things actually needed time. But if for you feel like you can replace them with vectors, it is okay. But all I believe these things are technical. Yeah, because what if the UNEB chooses hyperbola? Yes, but you have to listen. Let me put here the word so that people who just see the workbook, no people are good at judging. Let me put here, listen before you judge. We have people who are good at judging. So I'm saying, if at all you don't want to ignore them, and during your course of studying, they turn out to be easier than vectors, which I doubt. Which I doubt. It's like saying carbonyl compounds are easier than alkenes. You can understand, like they're easier than alcohol. Yet it is in alcohol that we find this esterification, which is esterification is the mother of carbonyls. So I literally don't get it when someone says that geometry is making more sense than vectors. Then you are not the same person. So you people, do you realize that when you ignore the whole of geometry, you have only and only sacrificed these marks? the 5. Only 5%. That's what you have sacrificed. That means you are working out of 95%. But if you feel like you also need that 5%, remember section B, we don't need it at all. You perfect the 7 questions. Out of the 7, you look for 5. You people realize that if a paper is having 8 questions and I'm supposed to attempt 5, why do I need to know everything that is taught in class? Can't I pick some instead of wasting time in mastering a lot? I invest time in perfecting some, but under guidance of the tutor or your teacher. You get? So when you leave out geometry completely, you are just putting a single number in section A at risk. However, if you perfect the first 4, which ones are the first 4? Trigonometry, vectors, algebra, and calculus, and you feel like, yeah, you can now come and first handle only section A questions of geometry, so that if it comes by chance a question can reappear, you smash that. Then you go back to the norm in section B, period. If at all you're done with, you can handle now other subjects. All subjects are going to have plans. You go to paper 2. If the same has happened and dynamics, you can also do all the section. You stop there, my friend. Just now do more numbers in other sections. Pray to God that you have an open mind, you don't make mistakes. That is all. That is all that you've been needing. Don't stress yourself with dynamics numbers of section B. Don't stress yourself with geometry numbers of section B. They are hard. We just look at them in the papers we have done. They have a lot of unknowns. They have A, they have P, they have Q. Things are squared. Here ellipse, here parabola, here hyperbola. That circle also has a lot of properties. We have concentric circles, we have orthogonal ones, we have those that are touching externally at a single point. We have those that are intersecting like a Venn diagram. A lot of things. And they literally take time. They literally take time. But me, I believe you cannot do without algebra and triggers are a must. Calculus, you need it because it is carrying the biggest percentage. So you need it to survive. Then if for you feel geometry is better than vector, you can switch. And I don't think that getting the point of intersection between a line and a plane is harder than getting the eccentricity of the hyperbola, ellipse, or parabola. I don't think. So let me hope you've listened to me very well. I don't want you to judge. Yes, but what I'm telling you is the fact. And it's what is going to help us. Yeah, that one you have to be aware. So the same way we treated dynamics of paper 2 is the same way we are going to treat geometry. Leave out some. In Luganda bakiyita kutalafia. But something which has 99% chances. For me, the number of dynamics I knew it was momentum. It came our year and it had a mistake. All marks were transferred to the other section. Period. Instead of wasting your time, let me tell you, it is a wastage of time to be knowing geometry and not to be knowing permutations and combinations. Yet you're claiming that for you do algebra. UNEB is going to bring permutations and combinations in section B, just like 2023. And the number of geometry that came couldn't be done. It had a very tricky something where I had to borrow a concept from trigonometry to actually attempt it. So, please and please, do a lot of revision. Be following our plan. Make your own plan out of ours. Follow it every time you revise. Thank me later. Just don't move away from just be on that. Be obsessed with finding new questions in a section you ought to do in an exam, be it paper 1 or paper 2. Questions are all over the internet. Those ones you will get. Your mock bodies are going to set papers we shall give you. Your teachers will compile questions. Just load the content. Just load the rules and laws as I've listed them. Be a student. When a teacher enters going to teach a parabola, you move out. You don't want to contaminate your mind. And don't say that I'm the one who told you. Then after you feel like the other ones have been mastered, you can now come and force yourself to understand. However, I've given you what each topic contains, what each topic contributes. You can edit your plan. But my advice is, if you are saying that I will do algebra, just ensure that all the 9 plus the 2 notes are on your head. Because you've seen that setters are biased. They set what they want. Provided the syllabus book mentions that this and this should be known by the students, they will set whatever they want. Don't be this person who knows a little on each. Those ones fail very well. Yeah. So that is the end of the facilitation, basically. Basically, that is the end of the facilitation. About math 1, drafting a plan. So don't expect me to teach you anything in geometry this holiday. Why did I say that by the end of this people are going to be in position to do at least 70%? 70% of every math paper. For me, I knew that some things are talked about them already. A case in point. Let us go to this paper. Let us begin with the mock paper. Someone should be adding. I want to show you something. Someone may be like, now, where is the 70%? We have not learned anything new. But the guy was saying by the end of the seminar, we are going to be in position to do 70%. Number 1, we have not done. That one I agree. Number 2 is differentiation, which was done in your schools. So those are 2 marks. Number 3, geometry, I skip. Number 4, I taught it myself. Number 5, series, I taught myself. I'm adding marks. I'm adding marks here. So someone else should be adding the marks on the calculator. I don't want to give a wrong final answer. Number 6 is trig. Those are 5 marks. Yes, this one is ratio theorem, which I gave you as personal work, then you refused to read. Hey, and no one handed in. Number 8 is area and a curve. That one I've not taught. Number 9 is trigonometry, which was taught. Number 10 is polynomial, which was taught. Number 11, I taught both inverse trig and the substitution. Hey, you're going to get surprised when you have all the 5 numbers. Number 13, Maclaurin, not yet taught, but small changes I believe were taught. Those are 6 marks. Complex numbers, they are saying a point C corresponds to this one. Let me see. Z, show that the locus, the circle, that one, okay. I've taught part, but I'm not going to count those marks. I'm considering considering part B. I'm considering part B. I'm considering part B only, eh? I'm considering only this part B. 7 marks. Then this one, number 15, vectors. What are they saying? Find the equation of the plane. I don't have not taught. Intersectional. Show that PR and these ones, because you have PQ, showing that they are perpendicular. That one we did today. Show that the dot product is a 0 plus 3. So, number 17, DE, which we have not taught. So, for me, I've counted 73%. Is it the same? Is it the same as what you people are counting? Is it the same as what you people are counting? Because the aim, the target was someone to live when they can at least get a 70%. That means if you sit down, you try out this paper. If you sit down and try out this paper, ask yourself, can I get the 73? Because now what is going to stop you? You are doing it in your own time. You can even use 5 hours. Let me tell you, the moment you do this paper and get a 70, you are going to get motivated. For me, one thing that used to motivate me was me doing papers at a very early age. When I was in senior 2, I could do senior 4 papers. Okay, I used to like national exams so much. In that, when I do a paper, a national, I was in senior 2, so I was forced to read a lot of chemistry. I completed chemistry in senior 2, third term holiday. So I came in senior 3 first term. I used to do senior 4 papers. I used to get 80s and 90s. That thing motivated. Those objectives, the 50. I didn't know moral concept in senior 2. So I would remember they were always 10 or 11. I could get 70s in objectives, like nothing, 70, 70, 74, 76. Because things were very obvious. They were very obvious. Let me tell you, the day you said a midway standard paper. You are in senior 6 first term and you get a 65. That is a credit 3. My dear, you are going to get the A. But all that comes after planning. You'll be like, let me squeeze this algebra. I get the 34. You understand? I get the vectors and trigonometry. I squeeze those 34 to make it 68. Then I come to calculus. I look for the 2 marks. And it is very possible. You just force yourself. Just force yourself, even when nothing has been covered, just to get motivation and be like, if in this national exam I can get a 7 as first term, then I'm somewhere. Let us go through the UNEB paper. That one has been UNEB. Now, the other one, by that has been a UNEB paper. Right now, where you are, you can get 73. Guess what? After my next lesson of complex numbers, let me tell you something fun. These things in my next lesson of vectors, even if you tell me to teach them today, you are going to be in position to do these parts A, B, and C as per the plan. So that means even these 9 marks, you add them to 73. That is 82. My next lesson of complex numbers, the moment I say that I'm teaching complex numbers, this part A, you are going to be in position to do. Those are more 5 marks. 82 plus 5, that is 87. In senior 5, this is a UNEB paper. Number 16, you cannot do completely. Number 13, Maclaurin, that one I've promised I can teach. It is very easy if you know differentiation. What if I teach it? Those are more 5. Plus 87. Plus 87. You already in 93. A senior 5. Number 12, you can't at all. Yes. Let me see. Number 8, it is still very far. But it is integration 1. Yet we are doing further integration. Number 3, that one is Kutalafia, not done. Number 1, permutation and combination is not done. So you realize that this 73 is now. And in next week is 87. Why do you wait for 100% to get 90? You start with 87%, and out of 87%, you get a 60. That's how you can be in position to get a 70 when it is 100%. Do you know what this means? This is a national mark. That is a national mark. So you people, you have to be, even if you tell me that you leave today when we can do these 9 marks, then also when this complex, remember what I told you in the morning, that my plan was vectors, complex numbers, and trig. My plan was to pick 2 of them, and also plus these 5, plus 14. So those are 14 marks. So I'm saying that even this one can be taught. This one needs 30 minutes. Maclaurin is easy. So those are 20 marks. Hey, 20 marks plus 73, that is 93 actually. I just didn't add on the other 3. 93 next week. Senior 5 student. Then you say that I cannot get the A. Why? What is hard? But the problem is raising the 80. Raising an 80 means that you've done a lot of numbers. That means you are blessed. You have wisdom, you have knowledge, you have God's grace. You are gifted, you are anointed, you are blessed, everything. You are working hard, you are working smart, you are strategic, everything. So calculating these things is easy. But calculations actually give you morale, showing you that these things are actually possible. Let me see. Let me sit down and see whether I can get the 87. Hey. Hadi. Wakata moko. Let us see now our next week. Here our next week is actually 93, not 87. 93. You remove 23 marks for errors to get a 70 that we are targeting. Hey, 93 next week. 73 now. That if I tell you that do this paper now, you show me out of the 73, how many can you get? A serious student will do this paper. You will do this paper, send it to me, you get a 50. When you get a 50, for your A is there already. 23 marks for errors, inclusive of what you've left unanswered. So we are going for Wakata. This has been UNEB. This has been UNEB paper 1. Now Wakata more. Number 1, complex number. I taught you that one. It is for square root. Those are 5 marks. Number 2, trigonometry, you know. Number 3, I'm the one who taught you differentiation of trig functions. So I'm putting it there. Those are more 5 marks. Tugende. Number 4, area of a triangle I've taught today. Wow. Number 5, geometry, we skip. Number 6, I taught myself, substitution, 5 marks. Number 7, I taught last holiday, myself series, 5 marks. Number 8, DE you can do. Number 7, complex numbers, and it is asking the modulus and the argument, which we are handling next. This one is saying, show that this one and this one are roots of this equation. These are things I taught, so you can do those. You can get this 4 marks. The mover have not yet, so you can only get the 4 of showing that they are roots and getting other roots. So there I will add on only 4 marks. Gende. Number 10, it is differentiation. I taught you myself trig functions and the logarithms. Hey, I even have the PDFs. We are now 15. People have reduced. Okay. Those are 12 marks. A and B are those points. Determine the position vector that divides. This is ratio theorem. I gave you the assignments. You just refuse to hand in. So the position vector, that one may take like 6, even this one, 6 down. So part S6, part B6, I'll add those 6 marks. This one, part B, is for the plane. That one I've not yet taught. Number 12, part A is binomial. That one is taught in every school. Consider only the 5 marks. I'm not going to consider Maclaurin 7. 13, curve sketching. Most of you did differentiation 1. So I believe curve sketching, you are in the know. 12. Number 14 is trig, showing and proofs. That is near 5. Term 1. Those are 12 marks. Number 15, geometry, we leave it. Number 16 is the DE, we leave it. Hey, so those who have calculated with me, for me, I'm seeing that now, the marks that you have, it is 81%. 81%, that's what I'm seeing. Is it what you guys are also seeing? Someone who has been calculating with me. Is it like that? Because I now want to get you that of next week. You'll be surprised even more. Is it 81? Yeah, George has told me 81. Now, next week, what is happening next week? Next week, I can teach this Maclaurin in just 30 seconds, 30 minutes, sorry, that is plus 7 marks. So, 81 plus 7, that is 88. Vectors, this part B, I can even teach now. You get these 6 marks. 88 plus 6, that is 94. That is 94. I repeat, that is 94. Complex numbers, what I was teaching next. What I was teaching next is this. Modulus and argument, even the mover. You understand? Plus 8. 94 plus 8, that is 102. It is beyond 100 because we are choosing more than 5 numbers in even section B. So we have a lot of options. Hey. Next week. Now, let me remove one number. Remember, you are supposed, there are 8 and you are choosing 5. I'm removing 16. I'm removing 15. Then, let me remove. So, you'll be having the 60 marks in section B. Not so. You will have that car number, you'll have that car number, you'll have that car one. You will have the whole of this one, you have the whole of that one. You will have the whole of this one. That is next week. The number you will not be in position to do is this one of geometry, which is number 15, and then this one of DE, which is 16. So that means you have 60 marks already in section B. Next week, in a mock-up paper. Are you listening? When we come here, what you don't know is only number 5, which is geometry. And then this one, which is a DE. So those are how many marks off? 10 marks off. The rest you can do. This is integration. These are series. Those ones you can do. Then here, complex numbers, square root, I taught. A position vector, I taught. Differentiation and trig. So realize you only have 10 marks at risk out of 100. So that means that next week, you can be in position to get what? 90%. You have 90% marks. Why do you wait to complete the syllabus? Why can't you first test yourself and be like, out of this 90, can I try to raise 70, the target? Those are already 20 marks off. The day you do this paper, even if you get a 60, you will be very happy and motivated. That 60% is a motive. It will push you to read harder and harder. Force yourself to doing things you think, make standard papers your friends. What you've not covered, leave it out. Don't copy from a solution book. So now 81. Next week we add on 9 marks. They're even 102. But remember, we have removed 12 marks for one of the section B numbers. So I don't know what you people actually want. That means even if we stop learning Math 1 next week, I should even say at least 80%. I would have said at least 8, but it is supposed to be 70. So that all the papers, even if you get the paper from where, all the papers will be favoring us. That's why I said any random Math 1 paper. So I think you've seen our target. So go back, see the topics you think you can do at national level. Make sure you go through a lot of papers, handle questions under that branch. When you reach an exam, do an exam in 1 hour, hand in. People will be like, hey, this person has not used their time well. Maybe they have not completed. Yes, you have not completed. You have not done geometry. But you've done your trig calculus because you practice a lot of numbers. So what you've done is actually direct. With the time, I will teach how they prove answers, but that is done in second term, towards the end and then third term. Teaching kids how actually each of the answers you get in an exam are proven right. That will come in when you've done personal practice. Passing is so easy a thing that if your plan is straight, possible. Your plan should be smart. I don't know how that smart is like I said in form. Specific, measurable, achievable. R for what? Forgotten R. Then T over for what? But it should be smart. Especially achievable. Don't just handle things that cannot be achieved. R is realistic. Then T, realistic, yes. So let something be real in that it can be achieved. Measurable, because something measurable is achievable, and that means it's realistic. Then T, time bound. Yes, exactly, time bound. That in the remaining time you have, you can achieve it and do it perfectly. Yes, thank you, George, for those who had forgotten the full formats of those things. So you realize that even at your level, you can look at a standard paper and have some 70 marks. Why not to try them out first and see that out of the 70 you can get a 50? That is clear indication that out of 180 is possible. Have that realistic anticipation that things are actually possible. Yeah. Now, you listen. Let me first welcome a few questions. As people suggest, as people bring in questions, you are 14. Let me see if my people are here. There are those who just decided to be on. Emasi Yaduse, Nguga Kwali. You know, there are those who are dozing. At least I'm happy that Alison is here. See, she prayed for us. Melody, Nachiganda, Yusufu. Nachiganda, if you are not dozing, you raise up your hand. Nachiganda, azukuse olwidde Nachiganda. Manyimu Abaganda mubaako n'empewo. So, what is our plan? That is my plan for Math 1. Literally, you do as I've told you, then you read other subjects. You pass. You pass. Math is a subject that can be actually passed. That one I'm sure. So may I believe with whatever we have talked about paper 2 and paper 1, things are possible. So I want someone to you either tell us in the chat, or you raise up your hand. You tell us, how is our plan? Is it risky? Or you see that things are doable? Hmm? What is your comment on what we have been saying so far? Hmm? Putting the dosing aside. Mwe mugamba ki? Hmm? What is your comment? Perfect. On my side, the plan is okay. Then others, the night is still young academically. I agree with you, sir. Yes, you have other subjects to read. Or you be with your work plan for the whole of next year. You just thank me later. Even physics. One time I'll come here and tell you about physics. You'd even be surprised. That one is the best. That one has the best plan ever. But Math 1 and Math 2, please think so much. Realize all our plans are good. How? They are only risking 5%. And of course, you cannot pass without risking. It's like getting rich. You cannot get rich unless you have risked. So risking can actually, you know what they call risking only 5%. Where after working on the 95, you can actually buy time for the 5%. You get? You just need to have plans that are time bound. Yes. So, please do for physics soon. So I need the people to tell me what we should do in the remaining time. Hey, because you have 3 hours. What should be done in the 3 hours? You advise me, because me, I'm very sober. I'm just worried about you. Hey, because the people here, now 14. 4 are dozing, 10 are sober. The 10 who are sober, 5 may be half tired. And making a lesson where only 5 people are sober, I don't know. You advise me. You don't send messages to me. You send messages to everyone. Send messages to everyone so that people look at what you guys are suggesting, then we see what we can do. Hey, I've told you the plan, so you use the plan and see. You may say, hey, next week is very far. Let us first secure some marks. Hey, two people are saying we study vectors. So you have two people who are supporting vectors, then others stop dozing. Then others, what are you suggesting? Please, Alison and Edgar, don't doze. Yusuf vectors, IJ for agreed vectors. Now people have fallen in love with vectors because they are sure if vectors are covered, have Micah question in A and Micah question in B. That is nice. Paula, Paula is seeing messages, but she's not here for the lesson. Let me first tag her. So I have how many people? I have Yusuf, Jeff, Alison, and Eddie. I told you. Then others, why are you quiet? Now people are 13. Let me tell you, we are going to remain 5. Hey, even George. So those are 5. Okay. So I think let me save this one. Let me save this document. I open another one where I'm going to continue with vectors. Tomorrow we have that of chemistry. So tukyali soba. Mirembe. Where is my pen? Where is my pen? Here. So that is the end of the facilitation. Courtesy of Simos. That is, let me save this document. I get another. So you people, you can have a break. The problem when I give you a break, you are going to doze. Let me give you a break of only 5 minutes. So at exactly 1:45, as I save this document, I bring another workbook. 1:45, we are continuing with vectors. Because that was the morning promise that we are continuing with vectors. So this is pure math cheat code. Pure math cheat code. think even these little papers we should save. So this was the check. Okay. So you take a screenshot, you tell your friends in the group that we are continuing with the vectors. Hey, you take a screenshot and tell them the night is still young, vectors we are continuing.